Welcome to the Better Health Guy podcast, where we take a deep dive into complex chronic conditions and explore ways to build resilience, improve vitality, and achieve better health. To stay updated on Scott's work, you can sign up for his newsletter in the show notes, where you'll also find ways to support the show and help make more episodes like this one possible. If you find the podcast valuable, please subscribe, rate, or leave a review, as it helps the show reach additional listeners exploring similar questions. The content of this show is for informational purposes only and is not intended to diagnose, treat, or cure any illness or medical condition. Nothing discussed on this podcast should be considered medical advice. As always, please discuss any health-related decisions with your own personal medical authority. And now, here's Scott, your Better Health Guy.
Welcome to episode 236 of the Better Health Guy podcast. If you are seeking new ways to create better health, I might just be your guy. Today we explore the microbiome connection, optimizing health from the inside out with my guest, Dr. Jason Hawrelak. He is a researcher, educator, Western herbalist, and naturopathic physician with over 25 years of clinical experience. He earned his PhD examining the capacity of probiotics, prebiotics, and herbal medicines to modify the gastrointestinal microbiota, and teaches worldwide on the topics of microbiota modification and gut health. He has published extensively in these areas, including 20 textbook chapters. He serves on the Medical Nutrition Council of the American Society for Nutrition and is a fellow of both the American College of Nutrition and the Naturopaths and Herbalists Association of Australia. He maintains a busy telehealth practice as lead clinician at the Hawrelak Gut and Microbiome Clinic. He is Chief Research Officer at Probiotic Advisor, which offers a searchable database that enables evidence-based prescribing of probiotic products. He also founded and serves as lead educator at the Microbiome Restoration Center, an online educational platform devoted to training health professionals to become microbiome clinicians through its flagship courses, naturopathic and functional medicine approaches to gastrointestinal disorders, and advanced microbiome manipulation. And now my interview with Dr. Jason Hawrelak. I am honored today to talk with Dr. Jason Hawrelak on the connection between the microbiome and optimizing health from the inside out. Thanks so much for being here, Dr. Hawrelak.
You're welcome, Scott. I always love chatting about microbiome. It's like my favorite topic for a long, 26 years, actually. I've been researching this area, so it's been a favorite topic for a long time.
I was going to thank you for pulling up a stool, but I thought that might be too much of a pun there.
I like stool puns.
So tell us a little bit about how you came to focus on the microbiome in your research, in your clinical work. Was there a personal experience or journey that led you to making the microbiome such a focus and central part of what you do in helping so many today?
Yeah. It was my final year of my naturopathic training, and there was a lecture put on by Professor Stephen Myers, who's a medical doctor and a naturopathic physician and a PhD scientist. And he gave a talk on the role of dysbiosis and leaky gut in chronic disease. This is back in 1999. Yeah. And he's piecing together all these stuff, which was more so animal studies and things like that at the time. But it's just something about the top, and it's going, hey, naturopaths have always said, it all comes back to the gut. Hippocrates said it all comes back to the gut. And here we're piecing together with, research going, it's supporting that. And then right after, and that was essentially what's coming towards the end of my training. And I was like, okay, I approached him right after the lecture and said, I want to research this. I'm going to contribute to that body of the connections between leaky gut, dysbiotic, bacterial ecosystems, and chronic disease. And so I subsequently did my honors degree and then PhD looking at the role of dysbiosis. And we chose a condition that in the late 90s had a bit of research showing there's a dysbiotic ecosystem associated with, and that was irritable bowel syndrome. Yeah, and that was kind of the poster child of dysbiosis back in the 90s. You look at the literature, the stuff on some IBD, the stuff on IBS, but IBS had research from the 1980s showing dysbiotic changes in the ecosystem, and had probiotic studies came back in the 1950s showing efficacy for treatment of IBS. We're like, okay, let's choose that as our poster child of dysbiosis. And it really just gave me a chance to spend, my honors degree was 1 year Australia honors degree is like a research degree, and we were at clinical trial in that first year, and then my PhD went for 4 years, so 5 years of just like full time, just doing microbiome research and reading all the papers. And at that time, you could read all the papers on the microbiome. I think that's the incredible thing, is where we've gone from, I think it was 300 papers published a year on what we call the microflora back in the day, and probiotics and prebiotics. That topic was 400 or 500 papers a year. It's quite achievable to read as a PhD student. It's not a big ask, but you go forward now to 30,000 papers published a year. It's a different story, and it just shows how much that area has boomed at any time. But it's still, I'd say that lecture just of his, and he became my PhD supervisor later on, and he guided me through that sort of process. But yeah, I'm just lucky that I chose a topic that I was, one, passionate about, and two, becomes this, everyone's talking about the microbiome now, which was not necessarily the case back in the 90s, early 2000s. It was naturopaths, it was functional doctors, integrative doctors that were talking about the importance of the microbes, and conventional medicine, for the most part, was just ignoring everything to do with the microbiome. Like, they're just bacteria, it doesn't matter if you kill them, it makes no difference at all. And there's a small group of microbiome researchers even then who said these bugs are important. It does matter if we kill them. Antibiotics do have long-lasting impacts beyond just like the short impact on the microbiome composition, etc. And that went from a relatively small group of microbiome researchers to now there's like tens of thousands around the world, which is really, again, adding to why we've got such a huge body of knowledge now around the microbiome compared to what we used to have.
So dare I say, it sounds like you were deep in the poop of it back in the early days. So
I was, and I maintained my clinical practice. So as I was doing my honors and PhD, I still practiced too, because I wanted to make sure I didn't put my clinical training to waste, so to speak. But also, it's like, I think it flows into each other well, because you read studies, hey, look at this intervention, it worked great. Try it in the real world. Does it? Like, sometimes it does, in other words, and sometimes it totally doesn't. And you're like, my God, that, it's the studies so it works, but in reality, it doesn't work nearly as well as the way it shows in the studies, or you get these other sort of side effects at the time frame it comes on. So I think it's merged well, having that research hat as well as a clinical hat, because I think it also brings you bring clinical reality into research too, because you see some researchers who've just been research scientists for 30 years and they just don't know the reality of engaging with patients, or what patients do for patients, how to implement things. Like, sometimes I go to microbiome research conferences, and you look at the food that people are eating, you're like, you know heaps more about the microbiome than I do in certain little facets, but you don't know how to actually take your findings and clinically apply them in a way that's actually going to make people's lives different, or your own life different sometimes too. The first microbiome conference I went to Italy, because it's Italy too, I was just shocked at the food that was being served. But I was like, yeah, these guys are going to be all over the microbiome. They're going to have such microbiome supportive meals for everybody in the breaks and at lunch. And it was like, totally not. And that was
So let's set the stage then with kind of an overview of the microbiota, or the microorganisms living within us. How many organisms live within us compared to our human cells? How are the types of organisms in the stomach different from the small intestine, and again, different from those in the colon? What do we more commonly expect to find in each when we kind of move from top to bottom? Again, no pun intended. And how many different types of microbes does an optimal microbiome contain as compared to what most people today likely have?
So start from the top again. I mean, I suppose looking at the microbiome, it's like about 100 trillion cells. Yeah. And there was a time in which there was this figure thrown around in the microbiome literature that it was like 9 to 1. We had 9 times more sort of microbial cells than we did human cells. That's been sort of reevaluated somewhat to you see different amounts thrown out in literature, but it's probably 2/3 microbe, 1/3 non-microbe. I think it's probably kind of the area that we've kind of more settled at, which is really quite striking. And I think it's really shifted. As I said before, we go from being microbes not being important to researchers going, hey, bugs are important. These should be seen as a separate microbe organ, as equally important as your liver or your spleen is to your overall health. And then that skipped all the way through to where we're converging now to that we are holobionts, or meta-organisms composed of human cells and non-human cells that make us who we are. And how we influence those non-human cells influence how every single body system works. And that has become super clear over the last 20 years, from just, okay, these things impact what's happening to the gut. It's like, it's happening. What happens to the gut changes what happens everywhere. What would do to change the microbiome composition changes functionality everywhere, which is both like, it's striking, but it's also, on one hand, it can be worrying in terms of what impacts we're actually doing on our health through altering that ecosystem, because it is relatively, fragile to certain influences. And on the other hand, it's great. It's super empowering because we can change that. Yeah, it's immensely changeable. We can't change our genes, for example. We can change how they're expressed, but you can't change sort of some of the structure. We can totally change the microbiome composition. If you're willing to change your diet, willing to change lifestyle, implement prebiotics supplementation, you can make massive changes and completely turn around, a microbiome. That's somewhat easier said than done with some patients, which is, the clinical reality that you and I face is like, yeah, in theory, do this, and this, the microbiome would change a lot, but hey, we can't do this, and this now because of these other factors there. Yeah. So, and I think, again, that the connections between the gut microbiome and every sort of body system has now become super clear, that we can change how the immune system works, we change how the nervous system works, how the brain works, how the metabolic functionality works. Now we've got gut brain, kidney axis, gut brain, mitochondria axis, gut brain, or like all these different sort of gut microbiome axes, kidney axis, skin axis, all these things now, because we're tying all these things into what's going on in the gut. And even I was at a conference in South Korea a couple of weeks ago, a microbiome conference, and they're talking about the most common things they're finding in the human bloodstream. The most common thing are microbial metabolites, which makes sense. And we're still teasing out, naming these things, seeing what they might actually do. But there's a huge amount of microbial metabolites in our bloodstream, most of which are uncharacterized to date. And that's the microbes communicating with us and producing things that are impacting us. Yeah, because, they're part of us, really, is the best way of really kind of describing it. Yeah, and as ecosystem, kind of shifts, the oral ecosystem is relatively microbial. It's quite rich in number of microbes. Okay, you get different microbes there because you get some oxygen exposure, but there's different ecosystems between like the gum pocket and your top of your teeth, etc. too. And the oral microbiome is not really my thing. I know little bits about it, little bits about how to influence it, but my main focus has always been on the colonic microbiome. Yeah. So we go the stomach, relatively small number of microbes. People estimate like 10 to maybe 1,000 microbes per mil of intestinal, of sort of gastric contents. These are ones generally we swallowed. They could be streptococci or lactobacilli, some veillonella that we swallowed from our saliva. But usually the stomach acid kills the majority of those things that we reach into our stomach. Yeah. And then we move into the small intestine, and the first bit of small intestine is microbial, not very, rich, but as you move towards the end, it becomes much more so. So people talk about maybe towards the end of the small bowel, maybe 10 to the 8 bacteria per mil. And then boom, you go over the ileocecal valve and you get 10 to the 11, 10 to the 12, 10 to the 14, and some papers are saying now in terms of microbes, so far more microbe mass per sort of milliliter of content, and diversity also increases as we go, from stomach being the least diverse to first your small intestine be a bit more diverse. And then as you make your way through the small bowel, more diverse. And then in the colon, it's like a major increase in diversity from that point. Now, in terms of, what's a normal level of ecosystem richness, because richness, diversity is a metric that has two components. One is the richness of the ecosystems, like how many species are present or how many genera are present. And two is the evenness. So how dominant are they, or how spread out they are. So we ideally want to have it like not be too dominated by 1 or 2 species or 3 species. You want to have a nice spread of things. Yeah. So you want it to look like a tropical rainforest rather than a plantation. Essentially is what I always tell my patients. It's like, you could have 150 species of trees and an acre of rainforest, but if 80% of those are one species, it's not going to look like a rainforest. It's going to look like a plantation. But if it's actually have 10% this, 8% that, 12% that, 2%, 2%, 2%, it's going to look like a diverse rainforest. That's kind of what we're aiming for from a microbiome perspective. So the diversity metrics we often will see, like the Shannon index, will be looking at both those components, for example. But in terms of richness, getting at like a number of species present, there's one paper looking at Westerners that maybe 160, anything below 160 was abnormally low, looking at a couple of the labs that are doing shotgun metagenomic sequencing, which is to the kind of the highest standard, the best technology to assess microbiome composition that we have access to today. Like Tiny Health in the US, for example, is a lab that offers that, and they have less than 145 species they'd see as low. And here in Australia, we have a lab called Microbial with the shotgun sequencing too, and they have about 110 species or less would be considered to be low. So for me, it's like they're not too dissimilar, 110 to 160 in that range between the published literature and what the different labs are saying. So you can kind of have that as your baseline. Anything below, for me, anything below 160, I'd see as abnormally low from a species perspective. And I'm also looking at number of genera present too. So most of your listeners are probably familiar with it, species genera stuff, but Lactobacillus is the genera, Lactobacillus acidophilus or Lactobacillus rhamnosus. Those are the species. So you can have numerous, species within a genera. But I look at both those bits. I look at the number of species present, but I look at the number of genera present too. And I'm aiming for what you see in Westerners often is 100 to 150 different genera. Yeah, that's what I'd say the norm for Westerners. So the people who are below that point, or ideally we're trying to aim for above that point. In terms of spectrums that I've seen in clinical practice, lowest I've seen is 12 in someone who is on long-term vancomycin, and they were all the E. coli, Klebsiella, like really nasty microbes as well. Although there's a little bit of lactobacillus too, to the highest being like 700 some. Now, to give that sort of spectrum. Yeah. And these are, people in Western nations, but definitely those that have had, in my practice, the most rich, species-rich and genera-rich ecosystems are those that, grew up in a more sort of rural setting outside of cities and avoided antibiotic use as kids. And they were like born vaginally, they were breastfed, not given antibiotics when they were kids, grew up eating a whole food diet, avoiding processed foods, and not much antibiotic use, if any, in their sort of more adult years or little. And those ones have got the richness there that still exists. And I suppose it's also, we inherit it from our parents too. So, if our parents took a ton of antibiotics growing up before they had kids, then that impacts what they can pass on, because you can only pass on what microbes you have. Yeah. So if you actually only have 150 species, that's all the best you can pass on is that, and most of us will be gifted, say we're gifted 200 species and then antibiotics here, antibiotics there, this, that, Western diet. By the time we have kids, we might only have, 160 of that 200 species left, for example, and that's what we typically see. And then that means that's why we're seeing this dwindling of the microbiome in terms of richness over time in Western nations, because, each generation has less microbes to start with to pass on to the next generation. And then we're, exposing it to the, Western diet, antibiotic use, et cetera, which reduces it further with every single, generation.
I think that we commonly think about the gut as being somewhat self-contained, and we don't think about the broad-reaching implications of our microbiome. You already touched on some of these different axes that affect the entire body. So when we're thinking about the microbiome, the microbiota, the organisms within us, are we more concerned about the pathogenic organisms being present? Are we more concerned about a lack of sufficient beneficial organisms and microbial diversity being present? And then how significant are imbalances in the development of chronic health challenges? What are some of the types of issues that we might see when the microbiome is dysbiotic?
All right. Well, in essence, all those factors you mentioned before, like for some, like this will differ per patient, and in terms of what we will deal as clinicians in Western nations, it's all those. For some people, it is, if I have a Crohn's disease patient recently did a microbiome assessment, they were like 55%, proteobacteria, which is mostly E. coli, Klebsiella, Citrobacter, and Enterobacter. It's like, that is not good in terms of gut health, is not good in terms of overall health, because they're actually absorbing a huge amount of endotoxins, and you're spot on. It's just that Alessio Fasano is famous for his saying, but I think it's very apt. It's like, what happens in Vegas stays in Vegas, but what happens in the gut does not stay in the gut. Like, it's such an easy way of trying to remember. Just keep that in mind, is it totally doesn't, and the more research we're doing, the more we realize that these bacterial components, both positive and negative, are being absorbed in our bloodstream all the time and totally influence all of our different systems. Yeah. And this is becoming more and more clear in terms of the disease states we now associate with dysbiosis. It's like there's almost no chronic disease that we will see in clinical practice is not now associated with the dysbiotic ecosystem that's driving it. Yeah, and that can be very high levels of proteobacteria, like I mentioned before, like E. coli, Klebsiella, et cetera, that have very pro-inflammatory endotoxin on them. And they grow endotoxin like we grow hair and nails. It's not like it's not a toxin they're actively secreting, although they can sometimes do that too. It's just something that they grow, and they're just releasing as they die, and as they live a little bit, they die releasing more. And it's just happening 24 hours a day, 7 days a week. You just have this, very pro-inflammatory driver coming from the gut. And that level of proteobacteria in someone's gut can go from like 55%, which is, the very high end of the spectrum, to 0% in other patients, which is the very low end of the spectrum. And then you have, the lack of beneficial species playing a role too. You have the ones that are making short-chain fatty acids. Particularly, we talk mostly about butyrate for good reason, because butyrate is like, a bit of a super molecule that has such wide-ranging effects, not just in the gut in terms of it's the main food source for colonocytes, totally is, but it's working systemically to have anti-inflammatory effects and heals the damaged blood-brain barrier, improves insulin sensitivity, reduces neurological inflammation, helps us generate new neurons, improves mitochondrial function, helps induce mitophagy. It's a really amazing substance, butyrate. And that's just one of the better characterized compounds that are coming from the microbiome. And we're, as I said, we're just kind of scratching the surface there currently. And watch the next 15, 20 years, it's going to be focusing on what metabolites, bacterial metabolites we find in the bloodstream will be the next area of booming research rather than just, what bacterial species are in the gut, which, is obviously still going to be important because they're driving that, but it's just, we're going to be teasing out more mechanisms of how these interactions, are occurring. Yeah. So definitely you see high levels of problematic bacteria species. And then you have high levels of what we call pathobionts as well. So pathobionts, so we've got, I'm talking about patients, we have the good, bad, and the ugly is a nice, easy way of remembering it. You've got beneficials, which generally, except for in extreme cases, are going to be beneficial in your gut. Yes, you have 80% of it might be problematic, but it's like a rare scenario. Like bifidobacteria would be a classic example here. Lactobacilli, Fecalibacterium are three that I put in that distinctly into that category as positives that, it's very rare for them to get to points where they are problematic in terms of their amount in the gut and the consequences. Like I've seen it, lactobacilli, I've seen it twice in my 26 years of practice, and people had Crohn's and abdominal surgery and had short bowel, and they had 20% lactobacilli in their gut instead of the usual 0.01%, and they developed D-lactic acidosis. So it's you can find the rare example where this can occur, but in real life practice with typical persons, you'd put those three in the sort of beneficial camp. And then you have the ones that are clearly problematic, like you might put Klebsiella and Citrobacter, Salmonella, Shigella, a bunch into that sort of Pseudomonas into that category, as well as other things like Giardia too, for that matter, sometimes amoeba too, that you put as very problematic members of the microbiome or potential members. And then you have pathobionts. So that these are ones that in the right amount are helpful and do great, useful things for us. But when they're too much, they can cause harm. And I would argue when there's too little, there's harmful consequences too. Yeah. And I'd even put Akkermansia is actually shifting into this category, I would say, based on the research in the last 5 to 10 years. It's went from being, it was solely beneficial. And we see all these problems in Western populations who don't have enough of it. And that's still all true, that last bit. It's just that there are some pockets where there's too much. Yeah, and there's too much. And that's actually causing a thinning of the mucus layer and causing leaky gut and allowing bacterial byproducts to come through. And we see this in Parkinson's patients and multiple sclerosis patients. And I've seen this firsthand where we do a microbiome analysis and go, ooh, look at that Akkermansia. You're at 15, 20% Akkermansia. And usually we're after 1, 2, 3% is normal and what we're aiming for, and a lot of patients I work with 0.001 or 0.1%. They're tiny. So we are actively trying to increase it in most amount of population. But you do have some people where it is actually present in excess and it is damaging that really important mucosal layer because it's living in the mucus. And if you have way too much of it, it's thinning the mucus layer and allowing sort of damage to occur. It just has a wider therapeutic window, I would say, than what some other mucus durators can.
And that mucus layer is also where the beneficial organisms are essentially residing, right? So if we have less of that mucin layer, doesn't that make it more difficult to have a healthy microbiome overall?
I'd say yes, but I think but most of the bugs, the ones that are residing right in it are relatively not that common. In terms of the breadth of microbes we have Akkermansia that's dwelling right in it. And then you can have almost the counterbalancing ones, which are Ruminococcus torx and Ruminococcus navis. They also live in that mucus layer. And generally people have one or the other. Yeah. And torx and navis have a much smaller therapeutic window. That, again, tiny amounts, they're actually good. But you go above that point, they actually thin that protective mucus layer. And for many Westerners, they're dominant by the Ruminococcus torx and navis axis, and they've got low Akkermansia. Yeah, and that is problematic. But you're right in that mucus layer is playing a very essential role. And yeah, it's feeding microbes too, for sure. And some actually reside within the layer itself. But it's mostly that barrier function to me that's missing. When we thin that, we're allowing contact between bacteria and our epithelial cells that doesn't usually occur, and bacterial components. And, essentially it's leading to leaky gut and, all the consequences that come from that when we thin that mucus layer. And we see this commonly in, put people on lower fiber diets. For example, we tend to see blooms of Ruminococcus torx and navis and the thinning of that mucus layer. And that's, one of the core drivers of, autoimmune disease and other sort of chronic Western diseases is that increased permeability of the gut. And put food allergies in that category too.
So you mentioned healthy or the good, those healthy organisms, which we potentially can grow with prebiotics. We can also supplement them exogenously. There's the bad, which we potentially might then use antimicrobial herbs or other things. But when we're talking about pathobionts specifically, when those are problematic, do you then approach them like a pathogen, or is the goal to restore the balance within the ecosystem rather than to eliminate them? Or is it a combination of both antimicrobial and microbiome support?
That really depends on what pathobionts are talking about and what level they're at, and what impact they're having on the patient. I'd say those things, yeah, and that's going to be what we feel as clinicians, because in terms of the known pathophysiological mechanisms, going, okay, well, this makes sense. This is the driver. This is at 80%. So if I had someone where, like Bacteroides, the genus itself, we'd see as a pathobiont that, it is important. It does play some nice roles when it's in the right amount. Great. But when too much, it's definitely a pro-inflammatory driver. Yeah. And sometimes you'll have a patient with 80% Bacteroides. And like, that's a lot. We want people, I aim generally to reduce that to below 20%. That's where I see basically the best health gains. And what the literature says to me is where we get the health gains from that genus. And we can do that often by changing diet, by going, okay, let's have more fiber. Let's bring in some prebiotics. That genus is particularly sensitive to pH changes. Yeah, so this is where we can make ecological changes. We can change the environment. We can change the ecology. Yeah, and how do we change the environment? We can change the pH, and we do that by essentially introducing fermentable fibers, broad range of dietary fibers, more polyphenols, and prebiotics like lactulose. Lactulose is by far our most effective tool for reducing pH in the colon. It reduces the pH far more so than other prebiotics or just general dietary fibers. And it reduces Bacteroides counts very effectively. And there was a paper published in 1997, which was, not far off from when I started my delving into the area, that showed 1,000-fold decrease of Bacteroides populations in humans after ingesting a lactulose. That was one of those pivotal papers to me. I was like, whoa, what is this thing? I was never taught about it. It causes 100-fold decrease in E. coli counts, 1,000-fold decreases in Bacteroides counts, increase, lactobacilli 10-fold, increase bifidobacteria by 1,000-fold. And I'm like, I wasn't taught this thing. The hell is it? And it turns out, it's for most countries, it's just easily available in pharmacy typically as a laxative. The US is an exception to that, where it's actually a prescription item, but everywhere else in the world, it's very easy to come by and very cheap. Yet it has a very profound impact on the microbiome, and has been researched as a prebiotic substance from the 1960s. They used to put an infant formula in the 1950s for trying to make it more like they call it bifidus factor, to more closely replicate breast milk microbiome, gut microbiome in babies, because the formula was, the ecosystem is totally different than it is in breastfed kids. So, hey, put some lactulose in the formula, and they became bifidobacteria dominant. Yeah, so you get some historical background about lactulose, but yeah, so that population is quite amenable to changing like that. Whereas other things, like I had, E. coli would be one of those ones that can skip between, pathogen and pathobiont. That having literally E. coli is totally fine, except it's particularly metablically active, microbe making things for us. That's cool. Vitamin K, for example, helps break down oxalates too, for example. So, it has some beneficial roles, but you get some strains that they're toxin producing, in which case they're definitively, let's kill the Shiga toxin producing strain of E. coli, or the ones that cause, hemorrhagic bleeding in the gut. Let's kill that because it's a pathogen. Versus, okay, you'd have normal E. coli present, but it's, not the pathogen producing or not the toxigenic strains per se, but they're elevated. But that might still be causing problems for this patient, where I might go, okay, well, that is a pathobiont, but I do want to reduce this population down pretty dramatically, in which case I will use the same strategies, because it's also relatively pH-dependent microbe that we can alter it by having more fiber. Lactulose reduces this population. GOS, and FOS, both of the prebiotics reduce its population, for example, the colon, through changes of pH, essentially. But I would use herbs to selectively target the E. coli and bring it down as well. I had a patient with Shiga toxin producing E. coli, and she had, that was at 5% of her ecosystem, and she had, bloody diarrhea, high calprotectin and lactoferrin in the stool. And so we were like, okay, well, let's target this with herbs as well as other things to change the environment. And then, within a week, within a couple of days of starting it, the blood mucus sort of stopped. And within 5 weeks, when we did the follow-up test, completely gone. And the ecosystem went from, it was over 6% E. coli down to 0.06%, and the Shiga toxin producing strain was gone. It's just like, yeah, so that one we're going to target as a pathogen. Yeah, and other pathobionts, Like I put Bilophila into sulfur-vibrio, which are key hydrogen sulfide gas producers in that category too. Having a little teeny amount of hydrogen sulfide gas is actually good. Just a little bit more than that, our colon sites can detoxify okay, but more than that, it causes a whole suite of issues. Yeah. And that one's often overgrown in Western populations because of our diet, essentially. And that one can be often changed through dietary changes as a consequence because it is so dietary driven. Yeah. So we often don't have to work with herbal antimicrobials per se or any other antimicrobial because we can modify people's diet to effectively reduce those populations. Yeah.
So let's come back to evaluating the microbiome and the pathobiome in terms of labs. You talked about the shotgun metagenomics or tiny health as being kind of your go-to. Some will use culturing. Many people are still using 16S sequencing as well. What are the strengths and limitations, or why do you prefer the shotgun method of testing? And what's proven the most helpful in helping you understand the person sitting in front of you and guiding your clinical decision making?
Yeah, great question. And I think I'm lucky enough to have been in this business for a long time. When I ordered stool tests 26 years ago, they were culturing and they told you about 4 bugs: E. coli, lactobacillus, bifidobacteria, enterococcus, or sometimes streptococcus, sometimes 4 or 5 bugs. That's all you got when you ordered a stool test 20 some years ago. Yeah. And that was culturing. So we grow those. Those ones grow particularly well generally so we can see. And then we're trying to make a assessment of someone's gut health looking at 4 species, which is kind of ludicrous now, but that's, the best that we had back then. So I've been observing the journey from that. And gold standard back then in the late 90s was culturing, but it was culturing where you do poo in the lab and they freeze it at minus 40 degrees under nitrogen atmosphere, plate it out, and they could grow out, a couple hundred species in people's stool if done really, really well. But that was a time-consuming, immensely expensive process that would never work in a day-to-day, working for patients, for research settings where you could set a whole research team to analyze one person's poo for 2 weeks. Sure, but it wasn't something that was clinically applicable. Hence, we had these ones that were much smaller. Let's get 5 microbes. That's clinically doable at a relatively cheap cost. And then we moved into essentially DNA technology to assess the microbiome. And from the first, which allowed us to see a lot more. And this also is why the microbiome's talked about heaps more now, is because we changed technology. With culturing, we can only see a limited number of microbes that were present. Most of the species of gut we couldn't see when we're using culturing because we could not grow them. We just didn't have the right tools or technology or understanding to actually grow these microbes. Yeah. So also we use DNA techniques. We're like, oh my God, we're seeing all these different species existing that we had no idea existed before. And we started off, the first access we had as clinicians was PCR testing, which is we're looking for known microbes going, okay, we know this, let's look for lactobacilli. And the test went up to 12. Remember, we went from 4 species up to 12 PCR testing. Yes, I can now see 12 different things of that person's microbiome. And then we kind of evolved from PCR to 16S techniques, which is still very accurate to the genus perspective level. It's not so accurate below genus level, but to the genus level, 16S is still accurate. Yeah. So when 16S test came out, I was so rapt because this is what was used in research settings. And the first lab offering it commercially at a low price was Ubiome, and they were charging like $50 to $100 a pop for this high tech way of assessing the microbiome. And my patients were paying, seriously, in Australia, $850 for a GI effect stool profile that told me about 12 species of bacteria. That was what we had as clinicians up until that point, going, oh God, I can look at 12 for $850, or I can look at the entirety for $50, And that was a game changer because it went from being, this test is expensive, I'll order a few people, where it's going to make a big difference to outcomes, to, oh my God, I'm ordering this test on everybody for $50. And that way, and you'd follow up, I worked out the best time to follow up. There's no point doing it. Probably seldom do it less than 2 months beforehand, except for when there's like a pathogen present that I'm trying to make sure I've eliminated adequately. And then the next movement of the technology was moving to shotgun sequencing, which is where we're at now. Yeah. And the benefits of 16S means we can see the entirety of the ecosystem. Okay. With PCR, we're only seeing what primers we have. And that's still a huge improvement on culturing, but it just means that it's also often very limited. So your PCR test will just have a list of certain species, whether they're kind of there or not, and whether they have a certain quantification. Yeah. And I don't think they're great at telling us about microbiome composition. in all honesty. I think they're good at spotting pathogens. Yeah, and I think they're always will have a really important role for looking at different pathogens. And that could be from worms to protozoal to fungi to bacterial pathogens, because we can often see them at a relatively lower amount with a PCR test. But they're not particularly great, I think, at telling you about the ecosystem in its entirety, because you want to be able to see its entirety. Yeah, and that's what they don't do. So a 16S test will tell you what every single bacterial population in terms of where they're at proportionally. And I find that a useful way of looking at the balance of the ecosystem. What's the relevant amounts of these different microbes? And initially it took me a shift from the 3+, 4+ stool test to we were president of the CFU program kind of thing to look at the proportion. But that's what the researchers all doing. So I had to make that kind of leap with the researcher going, okay, let's look at proportionality. This is what the new tests are doing too. And once you get your head around it, it's fantastic, because you can really see the balance and how things are interacting in such a different way when you can see the ecosystem it's an entirety. So you never go back to PCR once you've moved to 16S or shotgun sequencing to look at the ecosystem, because you just get to see it properly in its totality. And you also get to see determine richness and diversity in ways you cannot do with PCR testing or culturing. You can't, because you have to see everything that's there to give an actual accurate richness to the ecosystem. And you have to look at the spread and evenness of the ecosystem in its entirety to actually give a proper evenness score. And both 16S techniques and shotgun sequencing give us that capacity of seeing the richness, the spread, and the overall balance of all the pathobionts, all the beneficials, all of the potential pathogens will all be there. Yeah. And so we just have to look to the results to generally find them. The benefit of shotgun sequencing is it is accurate down to the species level. Yeah. So, you can look at how many species of Faecalibacterium there are, how many species of Bifidobacteria there are, and they'll be named accurately. And also shotgun looks at other things too, like they can look at viruses, and they can look at fungi and protozoal microbes too. Yeah. So you actually get, arguably a broader thing, because 16S is a gene that all bacteria have. Yeah, and each genus, their 16S sort of, I call it like a barcode, is unique. So we can kind of go, hey, there's 20% of this barcode, and that's a Bacteroides barcode. So we can kind of work that out. But you go below that point, we can't really see the species so well. But with shotgun sequencing, they take all the genes and they break it all down. So they go shotgun, it blows it all up, and they kind of piece it back together. And there we can actually see down to the species level, which is great. And one of the other benefits of metagenomics, like shotgun, is we can kind of see bacterial pathways too, going, okay, well, maybe this bacteria we haven't named yet, and we haven't been able to grow it in a lab to see all of its traits yet, but it does have this genetic pathway for breaking down oxalates or making hydrogen sulfide gas or producing histamine. So we can get some additional data from that, which can help fill in some of the gaps that we might otherwise have with 16S.
How representative of the broader microbiome is one swipe of a Q-tip? In other words, is that giving us a consistently reproducible picture? Is that telling us about both the small intestine and the colon? And then when we're using these types of tests, how many cycles of test bring in an intervention, test, bring in an intervention over what period of time is kind of average for taking someone with a complex chronic condition and shifting them towards a more optimized microbiome?
Yeah, I would say in my practice, and as I said, I did play with this a bit when Ubiome was around, because for $50 a pop, it was just like, let's check after 4 weeks, let's check after 6 weeks. For most chronic stuff these days, I don't bother checking under 2 months. Yeah, 2 months would be the minimum time frame. And often you'll see better changes by 4 months as well. So it kind of depends if you're going, oh, do make sure we're on the right track. You're implementing stuff. It's moving in the right direction. At 2 months and 4 months, we'll see greater shifts occur. So you might see, like, let's say there was like a teeny tiny amount of Akkermansia, or maybe even no Akkermansia showing up on your first stool test. Yeah. And I go, okay, let's target that to try to bring it back up. Because I always tell my patients at that early stages, I'm hopeful, optimistic that it's more of a below detectable levels issue, and that the test can't see it, but it's there. Yeah, because the test can go down to like 0.001%, and if it's below that point, the test won't see it, but it is there. Yeah, so I work under that assumption. So let's endeavor to feed it up and see what happens over the next 2 months. And if they can do everything well, 2 months later we'll do the testing. Oh, look, your Akkermansia is now there. Fantastic. Is it going to be where we want it to be? No, typically not by that point, but it's moved. But the fact that it's actually there and seeable, and we brought it up from below detection levels to 0.5 5%. It's like, great. But we still want it to be, 4 or 5 times more than that. So it's another 2 months later, boom. So usually by 4 months, we'll see, I think that's a pretty good window. Then I probably, if things are at a beautiful zone at that point, we may not test again, for another 12 months or something. We just want to make sure that things are still tracking in a lovely way, assuming that their medications are stable and their diet is stable and lifestyle is relatively stable. You might test again if they take a course of antibiotics, had a period of high stress, marriage broke down, diet really changed, then for sure should test again, because that ecosystem will have changed and you might need to be, more proactive again to help bring things back into a healthier state. Now, my experience has been in my reading literature is it is an accurate way. And it is interesting. Like you can tell patients, like you can follow up patients. And there are times where they've done this, where they follow up one patient, with a sample every single day for like months. And you can see this great consistency of ecosystem there. It's not much day-to-day variation until they took a course of antibiotics. And there was like, massive change. Then like 4 weeks later settled into a new groove from that point, which is always different from the original groove, but it's a new kind of groove. And, I can look at one and go, oh yeah, this is the same person's ecosystem, So I think there's a great degree of reliability in that perspective based on my take of literature and my clinical experience. And it doesn't need very much for the DNA techniques, because you just need a tiny bit of poo for those. Like when you needed to culture out the bugs, you needed like a larger quantity of stool to be able to plate out in different sort of petri dishes. Yeah. So you needed a larger quantity. And if you're still doing, seed, like looking for calprotectin and lactoferrin, occult blood and, digestive markers and short-chain fatty acids and pH, you still need a bigger chunk of poo to do those kind of analyses. But when you're just using the DNA bits to just look at the bacterial bit, a tiny amount is actually generally adequate. Now, I think you also mentioned something about small intestine versus large intestine. We're generally just looking at large intestinal populations. Yeah. Nothing to do with the small intestine. Now, the only time I'd say that's a little bit different as a clinician is if I have someone who's a positive SIBO test. So I've done some breath testing, positive SIBO, and I've done a microbiome analysis, and they have like super high levels of E. coli on their stool test. I might make that clinical assumption based on most, we know that E. coli is a common driver of SIBO. Yeah. And this person does have high amounts in the colon. Okay. I'm going to guess, or in the stool test, I'm going to say that, probably likely that it's E. coli related, or sometimes it might be like, they have like 15 times or 20 times more streptococcus than you typically would see. I'm going to make the assumption that it's actually streptococci that's driving it, just because we've got enough, data on the most common, we sample the small bowel and people with SIBO, we know the most common bugs, kind of we list them out. And then if we see them in super high amounts on the stool test, then I can make that leap. But I would never make that leap if I didn't do a SIBO test. You can't diagnose SIBO based on a stool test. I think it might be able to give you some clinical ideas and most likely bug overgrowing in the small bowel you might want to target more effectively. But you can't diagnose based on that. And if all you have is a stool test, you got no idea what's happening in the small bowel. I'm just piecing these together a bit, but it's really just a stool test that's telling us about the colonic microbiome. Yeah, and it doesn't even represent, the mucosal microbes so much either, which is a different thing altogether, which we can't easily test at all anyway currently. But I can say as a clinician that's used microbiome testing to guide practice with good results for a long period of time, that it is clinically a valid approach to do microbiome assessments, base dietary changes and interventions on the results, and then see clinical outcomes, both in terms of microbiome changes as follow-up, but in terms of changes in people's quality of life and their disease state, that is very clear.
You talked about looking at genus and species in terms of how you view the results of these microbiome tests. When we get something like Tiny Health back, in fact, most of them, they usually start with the phyla, and they usually break down the 5 or so different phyla. And so is that valuable information, or do you usually focus more on the genus and species level, and that's not tremendously helpful?
Great question. The genus species stuff is way more important, but you can get clues of what's going on and inflammatory load from looking at the phyla data. So I look at diversity first, then I move into phylum level data before I dig into the details. Yeah. So because we know like things like proteobacteria that I mentioned before have just very pro-inflammatory LPS as a class. There are some like the Enterobacteriaceae, which again is E. coli and cousins, that are really super inflammatory LPS. Yeah. So we'll be looking particularly at Enterobacteriaceae per se, or gamma proteobacteria as a family. But you can look at the genus and go, okay, I'm going to have to dig into that result because they've got 8% proteobacteria, right? Because that's going to be potentially a huge inflammatory load on the system having to deal with that LPS. Yeah. Also look at Bacteroidetes or Bacteroidota, as it's now been name changed to, because they're also gram-negative bacteria. Okay. And they also release LPS. Their LPS, thankfully, is like, 1,000-fold less inflammatory than we get from things like E. coli. But when it's there at 50, 60, 70, 80% ecosystem, it is still very pro-inflammatory for patients. I've had numerous patients where having high Prevotella or high Bacteroides has been the driver of their chronic fatigue syndrome, for example, and we reduce levels of those genera in the gut, and the chronic fatigue goes. You're going, okay, well, that's the LPS from those bacteria. And yes, it's less pro-inflammatory, but when it's there, that high amount is still an inflammatory driver. Yeah. So, and that's what sometimes it'll be like Verruca microbia, which is what Akkermansia belongs in. You might just go, hey, look, it's not there or it is there. Might give you a clue of, whether that's there. But I think, that is less important to look at from that level, probably more from the genus level. But, it is something I kind of have a quick look at when looking at the phylum level information. But I think the Bacteroidetes and the Proteobacter are the two that I put the most focus on. Yeah. And Firmicutes, I suppose, on a positive way, most of our bead rate producing species, the vast majority are in Firmicutes. Yeah. So I definitely will look at that and go, okay, what's that looking like? If that's low, then you know that by default, their capacity producing bead rate is going to be low. Yeah. And then all the flow and effects that come from that.
So let's talk a little bit about how you view SIBO, SIFO. Is the overgrowth of the microbe the cause of the condition, or is it more the effect, meaning that it's potentially downstream from the actual cause, where we might be thinking about the nervous system, the vagus nerve, the migrating motor complex, maybe bile flow, and other factors that set the stage for the overgrowth? How do you see SIBO and SIFO from the Hawrelak lens?
Yeah, I mean, I'd often see it as something had to drive the initial SIBO, okay? But then the SIBO bugs are definitely causing pathology from that point once they're in an overgrown state, where the release of LPS is driving brain fog and fatigue and mitochondrial dysfunction, depression, anxiety. I see this all the time in my clinical practice, every single week, that the LPS from SIBO bugs is driving that. I had an 8-year-old last week in clinical practice with fatty liver from SIBO bugs, an 8-year-old. Yeah. And started getting a metabolic syndrome and obesity. All those came on. It's just like, okay, well, and you have to tie it into, I think for her, from memory, is a course of antibiotics that drove the initial change. Yeah. So yes, I'd say that it's a consequence of some sort of initial driver. And that could be some things you mentioned before, but, traveler's diarrhea or food poisoning events, I think, are a common one in my clinical practice. Antibiotic usage is another common one in my practice. Opiate usage for, just painkiller, not even just like, as a recreational thing, but as like painkiller opiates are like a common driver of essentially SIBO because of they stop motility. Yeah. And I think motility is one of the things that comes with a few in those ones of like, when we get that sort of damage from food poisoning or traveler's diarrhea, we often will have a lack of motility and some damage to our motility nerves. Yeah. From that point on, and that will cause some stagnation, allowing bacteria to come up.
Are there then specific things, since we're talking about motility and migrating motor complex, that you tend to reach for? So there's a lot of conversation about thiamine or vitamin B1, but then we could be looking at tonifying the vagus nerve or other underlying drivers of the gut motility being impaired in the first place. What are some of the things that you maybe reach for to help support motility?
Yeah, so some of it will depend a bit on the initial driver of that too. Yeah, and some of it will be methane. So let's say they took opiates for a broken arm or some sort of post-op, and they developed severe. They're already a bit prone to constipation, but ever since the opiate, they just have had severe constipation and bloating, distension. Their brain fog has got worse, and fatigue has picked up. You're like, okay, and we do some breath testing. Oh, lo and behold, you're high levels of methane production. That's driving the slow motility. So sometimes we actually have to address the microbial overgrowth to deal with the motility issue. And I think that's very clear when it comes to methane, that is the case in point. But I think when it's like food poisoning or something like that, and maybe it's hydrogen, not methane, I think maybe the colonic motility is great. That's working fantastic, but just the small bowel is not. Yeah. In which case I'd often work on trying to decrease what I would see as prolonged sort of nerve inflammation that's persisted after the initial driving event. Yeah. And this kind of grew out of the post-infectious IBS literature. And because, my PhD was in IBS, like I was all over literature around IBS and, writing my different two different theses in that area was like, okay, well, we had data showing that, again, the food poisoning causing post-infectious IBS was known for a long time, and childhood diarrhea causing post-infectious IBS a long time, and it's seen to cause damage to the kind of nerves. So I'm working on using things like Microbial curcumin, which is just a well-absorbed curcumin extract, and things like Aberogast. So I'm going to use some Boswellia, to things that just have that anti-inflammatory effect. And there's other herbs like, I do use herbs like ginger for motility too as a prokinetic, but magnolia bark is the traditional Chinese herb medicine that's got some interesting research showing it's got the capacity of regenerating interstitial cells of Kajal. Yeah. So that have been damaged, it can restore their functionality. And it's been used in Chinese medicine for thousands of years for stagnation, bloating, distension, post-food poisoning. So we've got that long history of use. It's been used for motility formulas for a long time, and we have some mechanistic data showing it can improve functionality of those cells in the gut too.
So we kind of think of SIBO and SIFO on the one end, and then there's other conditions that maybe are a little more significant, like IBD or Crohn's or ulcerative colitis, those kinds of things, where fairly commonly people tend to put them into the inflammation or autoimmune bucket. I tend to still think that there are microbial drivers of those conditions.
Yeah.
How do you think of them?
Oh, yeah, totally. I would not put them in a typical autoimmune disease case. They're definitely driven by microbiome changes. That's clear. Like, for a disease like ulcerative colitis, we have 11-fold increase in like 40 years. No change in genetic, 11-fold. And you take people from like Japan who've got low incidence, you put them in America or Australia, their incidence goes up automatically right away from that point. It's so environmentally driven, and it's driven by microbiome changes. That's clear. And I say that as a clinician who's I've lectured on IBD, I've treated IBD cases for 20 some years now, and it just responds particularly also colitis and other types of colitis like collagenous and microscopic, etc., but also Crohn's, beautifully to alterations that change the microbiome, which is looking at dietary factors primarily, but home medicines can play a role with that too. But when I've got a patient who's got 50% Proteobacteria and active Crohn's disease, and the Crohn's is being non-responsive to any intervention, pharmaceutical or otherwise, it's like we have to treat that. That's a huge inflammatory driver coming from the gut. The amount of LPS coming into that in contact with the mucosa, let alone systemically in that particular patient, for example, is quite huge. So we have to reduce that load, and we have to increase the levels of butyrate producing microbes like Faecalibacterium, and then you start getting really positive outcomes in these people. And there's data around this too, and that in conventional medicine too, for that matter, where people with IBD that have higher levels of Faecalibacterium respond better to all interventions, whether it be steroid-based or infliximab and things like that. They respond better if Faecalibacterium is in a higher proportion, and if it's not there in lower proportion. So we've kind of got that data, and my clinical experience mirrors that too. So it's like we got to change the microbiome, and you get much better results when you look at these as despotic-induced diseases, essentially.
I think people listening would expect for us to talk about Candida or Candida in a microbiome conversation. So do you tend to think of Candida as more commensal or more pathogenic? Is it more the amount or the imbalance or the overgrowth that matters? And what are some of your go-tos for mitigating yeast and then potentially even broader fungal overgrowth with other types of fungal organisms? Is it to use antifungals to optimize the microbiome, or generally a combination of both?
The last question, the combination of both, the best answer there. I think the microbiome is an interesting area, and I think it's what's interesting about it is because it's such a generally a small player in the gut, which means testing is at a hard time seeing it. To get some conception there, small player, like the normal amounts of total fungi in the gut for most people make up 0.01% compared to the bacterial mass. So it's like 99.9% bacteria and 0.01 or 99.99% bacteria, 0.01% of that fungi. So it gives some conception around that, and which is why they can be harder to see on stool. The caveat here is we don't have great testing techniques to assess the microbiome currently at low levels, and again, the conference I was at this couple weeks ago in South Korea, there's a whole stream on the microbiome, which is rare. This is building, and they're like, okay, the normal levels of fungi in the gut are like, each individual species is like 100 to maybe 1,000 microbes per mil of stool. All right. And this is like really, really low. So it's not going to be seen easily on any kind of testing technology when it's in at normal levels. Okay. And this is what makes it harder to discern what's normal versus abnormal, because generally when you see it on a stool test, it's going to be abnormally high. I want to put that out there. Hence why, like, I used lots of shotgun sequencing on my my patients, and that tests for like, thousands of types of different species of fungi. Yeah, I can see everything that's there, but it rarely picks up fungus. Yeah, and it's because most of the time the fungus is below that threshold that can be detected. And at that level, I think it's probably, for the most people, is probably fine. And again, you can see there's some probablys in there because we need better testing to actually give us clear answers. I can say clinically, I'd say that the times where it does show up, where someone's taking a lot of antibiotics, they've been on steroids, something like that, where it's like, oh, look, you've got candida showing up here. Yeah, I'm going to treat that. Because that totally fits the picture, and I'm going to bring it down. And so it goes to your question. I think that having some levels of fungi in the gut is definitely normal. Yeah, and there's definitely some cross-feeding relationships there that are important. I just don't think with the testing techniques we've got now, we can give really clear answers about what level for sure is problematic, what species are definitely problematic versus those that aren't. Where I think candida definitely shows up as being a common one. Saccharomyces is also very common, which I generally would almost never worry about. Check on a test. And you sometimes have to tease out what food people are eating too, because sometimes they're eating lots of cheeses. The fungus is just coming from the food supply too. And I know most clinicians already look for that, but it is something that I find some clinicians don't. They assume that it's something growing in the gut rather than, oh, actually, that person's eating lots of blue cheese and camembert, and those are the yeast that are on camembert and blue cheese, and that's what's showing up in your stool test, and not these things. You stop eating those foods, they're not there anymore. So they're more temporary visitors versus the indigenous populations. Yeah. But I do think it's also, when I do have some where it is elevated, candida showing up on a stool test, and I do think it's problematic for them, then I will target a few things. I'm going to optimize the microbiome composition, going to optimize the environment to make it more acidic once again. It's things like candida actually behaves better when at a lower pH. Yeah, you have less of it growing. It's a typhae form, more in the bud form, so it's less aggressive and be problematic when it's in a more acidic environment. And going back to the research on lactulose, again, there was research in the 1990s showing that lactulose reduces candida count when ingested, going, that's fascinating. Again, those pivotal papers you read that really change, your practice approach is like, okay, we can reduce levels of candida by giving lactulose, which is because it's feeding, not because it directly suppresses candida, it doesn't, but it feeds bugs that do. So the metabolic byproducts of more bifidobacteria, et cetera, suppress the growth of candida. Either just through pH changes or directly through making some antimicrobial compounds that are, not quite elucidated, or increase lactobacilli counts, because lactobacilli often produces compounds that have antifungal qualities to them too. Yeah, that will keep populations in check. Yeah, it's still an area that we need so much more research into, and we need to develop better testing techniques that particularly us as clinicians can get access to, because I don't think shotgun sequencing is great because we can't see low levels of fungi. ITS is another technique that's used for fungi. Again, I don't think it sees low levels very well. Yeah, so this is an area where understanding may change over the next decade or two as we develop better tools to see what's going on. And like, okay, maybe having 10 to the 4 candida is problematic, but 10 to the 3 is not, and we'll be able to test that accurately at some later time point. Yeah.
So if we think about other fungal organisms, some thought leaders in the mold illness realm, like Dr. Neil Nathan, for example, will talk about fungal colonization in the sinuses and the gut from long-term exposure to mold in the external environment. And so I'm curious if you see that at all. Do you see that patients that you're working with who live in a moldy environment have more difficulty with getting their microbiome shifted in a healthy direction? And do you think it's possible that that could still be impacting the microbiome, but to your point that we're just not really able to assess that today? I know we do fairly commonly see elevation of fungal metabolites on organic acids testing, which then leads you to say, well, okay, where's that coming from and what do we potentially do about it? So do you think the external environment has any impact on our internal microbiome environment?
And I've worked with lots of people with mold issues over the years and doing microbiome assessment with shotgun, and I haven't seen any yeast fungal type mold overgrowth in their guts on that testing. As I said, I'm open to acknowledging that we can't see tiny amounts. I think to me it's also more unlikely it's in the gut. Listen, I think in the sinus cavity in the lungs, sure. Yeah, I think that definitely can definitely occur. I'm not so convinced that people who, unless you're on PPIs, which listen, a decent proportion of the US population is, and Western population is, in which case you're losing that capacity of stomach acid at all to actually lower mold or yeast load, in which case, yeah, okay, in that pocket of population where they're on a PPI and exposed to tons of mold all the time, I think it's possible that it could grow in the gut, but I think typically that would be a rare scenario. Sinuses, yes. Lungs, yes, sure. But in the gut, I don't think so, because the environment of the wall is quite different from typical gut. It's like the temperatures are different, the pH is different, oxygen dynamic is different, perhaps, or most key. But as I said, in some really despotic guts, the oxygen dynamic is really wrong, and maybe they've taken a PPI, so they've got no hydrochloric acid functioning anymore. You could start piecing together some things, but as I said, on my testing, it has not showed up consistently. Anyway, yeah. I think which leads, and part of the issue with the technology we have in terms of not being great at telling us what's going on from microbiome perspective, it means we're using indirect testing like oats. Yeah. And I do have some concerns around, what we're actually seeing, whether it's some of the stuff is food related or what's coming in the gut. Because I don't think we have exhaustive food lists of arabinose, for example, to make sure that none of it's, that's coming on the wee has actually been from your diet somewhere. We've got some foods, but we don't have the entirety of all the foods arabinose content, for example. So I'm sometimes worried that we're making a leap there that is not based. But again, if you're, a good clinician, you're teasing together stuff of history, environment, symptoms, and then this test goes up on top of that. It's a different story, but just on its own in isolation, I have more concerns around.
Let's dig a little deeper into the pH side of microbiome optimization. So, people are maybe doing things like alkaline diets or maybe alkaline water or things that claim to shift the body's pH. But how relevant is pH from a microbiome perspective? And are there specific ranges of pH within different regions of the gastrointestinal tract that then favor the beneficial organisms and discourage potentially problematic ones? And then building on the pH discussion, when might you as a clinician reach for hydrochloric acid in a gut health optimization strategy? Or are there enough potential risks with supplementing hydrochloric acid that would be something you would not commonly do?
All right, maybe I'll address the last one first. I don't tend to use much HCl. Yeah, very rare in my practice. And I do have some concerns when it's used causing harm when lower esophageal sphincter tone isn't good. Yeah, and this occurs with reflux. And this is going to be like almost blasphemy just from your listeners, but it's like, one of the early academic tasks was writing a textbook chapter on evidence-based treatment of natural medicines with reflux disease. So it gave me a chance to I want to spend weeks delving into the GERD literature. And of course, looking at the HCl GERD stuff, and it's like, hold on, there's actually no studies showing that people with GERD have got lower HCl output compared to, or less, more alkaline stomachs than those who don't. Like none in the human studies show. Generally, it's the opposite. They have normal or even slightly more acidic pH. That's the sort of, so it's like that was like, whoa, that's not what I've read in all these functional medicine trainings, but it is what the literature actually says. And I had a patient who prescribed some HCl, and actually when she had GERD, and actually ended up causing esophageal ulcers. So, it's one of those things that maybe, my experience was like, okay, there's no data supported for it, and it caused harm in a patient early on in my life. So, clinical life. So therefore I'm a bit cautious about it. Like only if people actually had long-term H. pylori, which definitively damaged their hydrochloric acid secreting cells. I'm like, yeah, okay. I'm okay using HCl for you where it's definitively needed. Otherwise I'm quite cautious around it. Now, in terms of what you were laying before, in terms of pH, two areas where the pH has the biggest role to play in the microbiome, I suppose, is the stomach. Yeah, where that really low acidity kills microbes when they're coming in. Yeah, and you put people on PPIs, and we see this. You do get molds and yeast growing in their stomach and other microbes growing in the stomach that otherwise are not. Yeah, this is why I mentioned PPIs before, because they're like really problematic by changing the pH in that area. And then the colon is the other area where it's very pH will completely determine what microbes grow and thrive versus don't. So in pH of 7, you have different microbes, different microbial byproducts versus a pH of 5.5 or 6. Yeah. And in general, most pathogens like growing at neutral pH, and most beneficials like growing at acidic pH. That is a great general tip to take with you, because it shows you've got a great capacity of altering the ecosystem just by changing the pH. You can totally suppress, Bacteroides overgrowth or E. coli or Klebsiella, some of the other ones that are really problematic, by changing the pH, by just changing it to an environment that they're not actually happy with. Yeah. And sort of like explain to my patients, if you've got like, a weed that likes growing in full sun and you cover it with shade, or vice versa, ones that like growing in full shade and you give them full sun, they die because the conditions aren't to their liking anymore. And it's like that with pH changes. So we can actually shift that. So things like Faecalibacterium, Akkermansia, bifidobacteria are butyrate producers that like it acidic. Yeah, they like being below, 6.5, and we tend to get better behavior of microbes from like our Bacteroides, which is that pathobiont category that, produces beta-glucuronidase and can produce ammonia, neither of which we want it to do. It does that at pH of 6.5, 6.7, 7, 7.5. It does those things. You bring the pH below 6, it doesn't. It can still be there, but it's not making beta-glucuronidase, it's not making ammonia anymore, not making protein putrefacted byproducts they're problematic, So we can alter sort of behavior by changing pH too. So it is an immensely useful tool. I mean, I think some of the from an ecological standpoint, the biggest shifts we can make to ecology are through changes in pH and changing in oxygen dynamics in the colon. It's those two things that allow us to make ecological change and really dramatically shift the ecosystem in a very selective way that encourages good bugs and discourages problematic species. So we don't have to go in with like kill, kill, kill. It's like, let's change this dynamic, let's change that dynamic, and the whole ecosystem will change.
So I want to come back to the oxygen in just a moment, but since we just talked about hydrochloric acid, another common thing people would reach for in the gut health realm are digestive enzymes to break down proteins, fats, carbohydrates. I think we think of that as helping with more assimilation of the food that we're taking in, but do they also have a role in microbiome health as well? If we have inadequate digestive capacity, which then allows undigested food to reach the lower GI tract and potentially feed less desirable organisms, can optimizing digestion with enzymes help to also contribute to a healthier microbiome?
Yeah, I would say yes to that. I mean, I think some things like protein is probably a nice case in point that malabsorbed protein reaches the colon, and malabsorbed protein in the colon kind of feeds pathogenic microbes, problematic microbes. Okay. So, and this is also an issue. People eat tons of protein too, because you're always malabsorbing a proportion of your protein. Regardless, if you eat tons of it, it's still going to have more reach the colon. That's been clear in human studies already. But if you are, malabsorbing it, you're going to have a higher proportion, and that does feed problematic microbes and contributes to, the colorectal cancer type metabolites and increased beta-glucuronidase activity, et cetera. So in a case like that, where let's say celiac disease and recent diagnosis and your villi flat and your pancreatic elastase is not really functioning that well, it's like, yeah, digestive enzymes are fantastic in that for both reasons. One, you're going to assimilate nutrients you need to heal up, and because you've been malabsorbing for God knows how long, because it's taken you 5 years to get diagnosed, to actually, helping reduce unusual things reaching the colon in larger amounts, because we don't normally have lots of fats and lots of protein bits reaching there. We don't normally have lots of sugar reaching there either. We normally have fibers reaching there, indigestible sugars essentially reaching the colon. Yeah, that's totally normal, but it's arguably abnormal in a case if you had a case of, again, looking at celiac case in point where lactose or fructose can be malabsorbed, at that point of diagnosis, and they reach the colon. Now, interestingly enough, we don't necessarily see dysbiotic changes with that lactose. We might get more bifidobacteria from the lactose being malabsorbed, not in the same way as we do with the unabsorbed protein, which definitely will do dysbiotic changes. And there's some data around unabsorbed fat that's less clear here, but probably causing dysbiotic changes to increase of proteobacteria when higher amounts of unabsorbed fat is reaching the colon too.
So the topic of oxygen is a very interesting one that I historically have not heard a lot about. It sounds like our beneficial microbiome organisms or beneficial microbiota are anaerobic and thrive more in low oxygen environments. So talk to us a little bit about that. How do we assess the person's oxygen level in the microbiome, or is that indirect? And then where that kind of led me to think a little more is, could things that increase oxygen exposure that we do regularly long-term, like hyperbaric oxygen therapy, or maybe ozone or oxidative therapies, could those negatively impact the gut microbiome?
All right, I'll answer the last question first. Yes, it's the answer. And we have that data on people with HBOT that increases levels of proteobacteria.
Light bulb moment.
Yeah, it does.
A big one.
It means, yeah, and it's important that people just aware of that, because it doesn't mean that you can't use these interventions because they might have other effects you're after. But you can't ignore the fact it's causing microbiome harm at the same time. If you want to get best outcomes for your patient, is that these things can be addressed, but you have to know they exist. That's the thing I always tell people. I'm like, oh, I didn't know that. It doesn't mean we can't use HBOT for things it's really well indicated for. It just means we have to be aware that it will induce generally blooms of proteobacteria like E. coli, et cetera, in the gut as a consequence of having more oxygen leaking through from the bloodstream through. So that is definitely something that occurs. Yeah. And it has to be on our radar. But you're spot on. And I think this is one of the things that has historically been problematic because people are like, oxygen's great. And like, all our good bugs like oxygen. No, that's totally wrong. Like 99.99% of the beneficial bacteria in our colon are so sensitive to oxygen that they die upon exposure, which is why we couldn't say that they even existed until we stopped trying to grow them in petri dishes and use DNA technology, because they're so sensitive to oxygen. So oxygen in the gut is not a good thing. Yeah, it's not remotely a good thing. So I think anything that's increasing oxygen levels in the colon is going to be problematic. Now, I think thankfully some of the things that people think do it, like magnesium oxide, don't. So thank God that's the case, because if you could freely just take something that's bubbling up oxygen in the colon, you'd be causing so much harm to your patients. It would be crazy. So we do not want that. And pathogens do. That's the thing, is the bugs that are really problematic, like E. coli, Klebsiella, Candida, all those things love oxygen. They don't love an anaerobic environment. Yeah, so that's the other way we can shift the dynamic a bit. And in terms of measurement, you're right, it's indirect. Yeah, so we can't. You're looking for microbes that like living in oxygen and ones that don't, who will get killed with oxygen. We're looking at the microbiome picture. And this you see not infrequently, where it's like, oh, your butyrate producers are all really low. The Calibacterium's really low, but you've got lots of streptococci, enterococcus, E. coli, Klebsiella, Citrobacter, and Veillonella. Those ones are often higher in an oxygen-rich environment. You're like, okay, there's obviously oxygen here because these bugs are really high, and you've got all the ones that are strict anaerobes really low or below detection sometimes. It's like, yeah, we need to change. We need to change that.
So can you then reduce the oxygen to cause those beneficial organisms to grow, or do you just have to support them more because of the higher oxygen? Like, what's the therapeutic intervention in an oxygen-rich gut?
Yeah, it is fiber, and it is resistant starches, and it is increasing butyrate production. That's the thing, because it all makes sense now when you think about it. But butyrate is oxidized by colonocytes. Yeah, oxidation, it pulls oxygen out of the gut lumen to burn butyrate as a food source. So we're not producing butyrate. We actually allow oxygen to build up in the colon. And this is one of the issues we see with Western populations who eat really low fiber diets, and people that choose, therapeutic diets that are low in fiber, are low in resistant starches and fermentable fiber, have the same consequences. You essentially aren't producing butyrate. You're not getting, butyrate's not being oxidized by colonocytes anymore, and you have oxygen build up, and you see this shift in the ecosystem having more oxygen-rich species present, and the ones that are anaerobics going down. So we counter that by feeding the microbiome precursors of butyrate, and in some cases we'd actually give preformed butyrate, or I would in this sort of situation, going, okay, particularly if you're on a really restricted diet and somebody and a person is eating chicken. They've cut out lots of food that's only that they can currently tolerate is chicken. And you look at the microbiome, like, oh my God, you've got 2% butyrate producers, and you've got oxygen-rich pathogens there. And it's just like, okay, we need to fix that, and we need to increase your dietary diversity over the longer term. But that's like a longer term process. It's not a here start eating 50 grams of fiber a day thing, because they'd be in horrific pain, etc. So, but butyrate as preformed substance is very useful from that regard, because that starts feeding colonocytes. They start oxidizing the butyrate and start pulling that out and changing the environment as well. And then the butyrate's also changing the pH.
So what we're saying there then is taking supplemental butyrate can help to reduce these oxygen-rich environments. But does taking supplemental butyrate then lead to fewer butyrate producers because you don't need to produce it?
No, it's a good question. No, it doesn't. And I think if anything, there's a little bit of research suggesting there might be a slight increase of butyrate producers when we supplement butyrate. It's not as much as someone might hope, but it's definitely not suppressing their population. And it's just creating an environment, particularly in those situations, you're actually it's going to help encourage the growth dramatically. Like in a more normal type ecosystem, it's going to have like a small increase of butyrate producers. But in an ecosystem that's that disrupted with really high levels of oxygen-loving microbes present, butyrate will have a really profound shift on helping the ecosystem, other butyrate producers grow, because you're changing the environment to one that it likes. I mean, I think there's some estimates that we make is 7,000 to 10,000 milligrams of butyrate a day on a high fiber traditional sort of diet. So giving some context around dosing can be important there too. If like, oh, it's giving 150 milligrams twice a day, I'm sure it's better than none. Don't get me wrong. There's studies showing it is better than none, but I think we can underdose butyrate in those situations, because maybe we should be giving 3, 4, 5 grams a day rather than 200 milligrams twice daily, to try to more replicate what it would be in a healthy gut. And I also think there's an area, and I haven't played much clinically with this yet because they're relatively new tools, and I'm thinking about this has just recently changed, but some of those postbiotic preparations like Thenobiotic, which is essentially sterilized poo. Okay. I was always like, I don't know how to use this because I'm using prebiotics and food to feed my good bugs, and I'm seeing all these great changes. Yeah, but there's this particular population who have, who just eating a couple foods. They can't tolerate anything. This is where I think preformed butyrate is really helpful. But I also think that those sort of Thena type, sterilized poo things, treatments can be very helpful because they're just providing the bacterial metabolites that should be there but aren't. Yeah, and that could help normalize functionality. Yeah, so this is where I think that probably the main sort of window of those tools will probably be is in those situations where the oxygen dynamics are really wrong, the diet is really not great. They've starved off their beneficial species. There are tiny amounts that are there, and yeah, we could feed them, but the patient can't handle any of those foods, any of the prebiotics currently. So we need to do some terrain modeling first and decreasing inflammation and working a few different axes there. But let's use butyrate and that sort of Thenobiotic type product to actually nurture the colonocytes who then pull oxygen out and start creating a better environment in a different kind of way.
So you've talked about the fact that by mass, bacteria is the most significant part of our microbiota. You mentioned the microbiome, that it's relatively small. What about the virome and even parasites? So can we still potentially be too bacteria-centric in our thinking? Do you see chronic viruses that thus are impacting the gut specifically and thus systemically? And where do you sit? The parasite spectrum usually is people think everything is a parasite or people think nothing is a parasite. I believe that with the shotgun testing, we can find some of the protozoa, but not necessarily the worm type parasites. So where do viruses and parasites fit into this conversation?
Yeah, so shotgun sequencing will definitely tell us about the protozoal bugs present. And some shotgun will tell you about the viruses. Like they can in theory, but not all labs provide that kind of data, But I know when I first started using Cosmos ID, who does sort of more work for clinical trial analyses, but they were doing some patient work for a while, and they could give you this whole data of all the different viruses that were picked up. It was like you could get like 60 pages of information from a microbiome report. It's huge, like too big to really tease through the individual patients. But it's just fascinating how much data you could actually get around that. I don't think we have a great amount of research information to give it too much informed opinion around the virus stuff as yet. And I go to microbiome conferences regularly, and this year was the first year I saw there's a whole stream devoted to microbiome for the first time, and a whole stream devoted to the virus stuff too. So I think this stuff research is building, and I think it give us another 5 years or 10 years. Sadly, it's going to take a time before I think we'll actually be able to piece some of these things together. Well, and going okay, what? Because they're just really starting to look at some of the virus bacterial interactions there, but the protozoal stuff is a bit, Again, we're teasing out those dynamics too. Like those bugs that, like blastocystis, for example, is maybe a nice example here that has gone from 25 years ago, it was seen as a pathogen that caused gut harm, to now seen as the great white shark of the ecosystem that actually has a very protective role in ecology and actually keeps bacterial populations down, particularly Bacteroides, by eating them because it eats bacteria. And it's actually associated with better health outcomes, better metabolic health, and better health, ecosystem health altogether. Yeah, and it's just like, whoa, that's gone from one extreme to quite the other as research has actually picked up on it. Because the original research was like, oh, I've tested people with diarrhea, they've got blasto, therefore the blasto must be the cause of the diarrhea, versus, let's check the healthy population. Oh, look, lo and behold, it's like really prevalent in the healthy population. Like I've got blasto in my gut, and I've got no gut symptoms at all. I got diatomeba in my gut. I've got no gut symptoms at all. And now we're seeing it's actually protective, and some populations, like the US, I think because of antibiotic use, has got low prevalence of blasto. It's about 6% based on the best that I've seen, whereas Australia, about 55% of us have got blasto in our guts. I think Ireland was like 40-50% too. It's interesting. Yeah. And it's very, very seldom in my experience, actually, and based on the recent research, a problem. It can be, but it's relatively rare. It's usually something else going on in the gut that we've historically blamed blasto for. I'm guilty for that too, of doing inadequate testing workups. Yeah.
In my more than 2 decades of trying to get my own health back, the first thing that everything was blamed on was blastocystis hominis.
Yeah, it would have been 20 years ago. That was like, that's it. Let's bomb you with antibiotics to try to kill this thing. Like there was a center in Sydney here that would give people 3 antibiotics orally, 3 other antibiotics indirectly at times to try to kill kill the blastocystis, 15 years ago, 10 years ago.
So what do you think about the prevalence of larger parasites? Do most people have worms, or do very few people have worms? And if there are worms, do we need to get rid of them? Or are they doing something beneficial for us?
It's a good question. And I think it probably, again, we have a dearth of good data in this area. I think that probably not all people have got worms. I think it depends on where you live, what you eat, what animals or nature you interact with. I think it's probably historically normal for humans to have worm exposures, and there's certainly people who think it's beneficial and for modifying immune responses, and will give worms for things like IBD, for example. It's like I think they can probably be useful in certain ways, but I also have situations where I've had kids who have failure to thrive to having too many pinworms, for example, or the pinworms are like driving the entire household mad. I'm like, yeah, I'm going to treat. If the kids like can't sleep at night, and then there's this, or the worms go from bum into the little girl's vagina, it's just like, nah, that's no good. We need to treat those things when they get to that extreme end of things. Yeah. So I think it's nuanced, and probably been in between that we levels of a little bit of worms. Probably for some worms, it would probably be good and probably beneficial, but if overgrown or very problematic. Yeah, but again, we need more data, which is something I'm going to come to a few times. But I think we do, because it hasn't been an area that's been well researched in terms of what levels are normal, could be beneficial. There's certainly some data around it, but I don't think they're universally problematic. I don't think everyone's got them. I don't think we need to be treating everybody, but I do often treat pinworms, for example. It's the most common one that comes out of my clinical practice.
So we touched on the idea that some organisms can exist along a spectrum from symbiont to pathobiont, depending on the host and the host environment. Are there some organisms, you already alluded to this with blastocystis, but are there some organisms that we are potentially over-treating in modern medicine because we label them as universally harmful? And very specifically, I'm talking about H. pylori. I see people that get positive H. pylori test and they jump to triple antibiotics. There might be some beneficial properties of H. pylori as well. So how do you view that one?
Yeah, I think you're spot on there, Scott. So I think the two that come to my mind would be H. pylori and blastocystis, that I think have historically and even contemporarily been like, oh, let's treat you with mega high dose antibiotics to try to eradicate this thing that may or not be an issue. I think with blasto, it's very rarely an issue. H. pylori, I think a greater capacity it is, a greater amount of people it is, but we also know, and there's definitely, there's certain data showing we have reduced risk of esophageal cancer, reduced risk of reflux disease when we have H. pylori present. So we've got some data around that, and it's been in that ecological niche in humans for hundreds of thousands or if not millions of years. Yeah. And it's only certain scenarios where it tends to be problematic, but it can be. And there are strain characteristics that make them more problematic too. And we know some of those ones can be elucidated on certain types of tests now, but not the whole spectrum of virulence factors as yet. Yeah. That complicates it. But for me, if I have someone who presents with lots of burping or upper gut discomfort and maybe lack of motility, lack of appetite, and I test for H. pylori on a stool antigen or a breath test or something like that, it shows up, I will treat. All right. Or if you have a scope showing with gastritis or peptic ulcers present, I'm going to treat that. But if it just shows up, particularly on some of those PCR tests that just show up, H. pylori, they're like slightly above the normal level, and they've got no upper gut symptoms, no, I would not treat based on. I might go, okay, let's do a antibody test or a stool antigen test to go, to confirm its presence by a more validated test to assess for that, which might help fill in some of those answers too. But if I had no upper gut symptoms and it showed up on a PCR test, or it shows up on a stool test and like a shotgun test occasionally from time to time, there's no upper gut symptoms, I'm not going to go into just treating it based on that. No, again, I might go, hey, I might again do a more standard sort of workup around H. pylori status to ascertain whether I think it's problematic or not. But I don't, because I think there is definitely arguments, and Professor Blazer puts through some great arguments for why we should be, being protective of H. pylori and how we might actually invite more larger pathogen into our gut by eradicating H. pylori, because there'll be an ecological niche that needs to be filled, and maybe something will come into that actually is more problematic than what H. pylori is for the majority of people.
So what I'm hearing is if you ran something like a GI map that showed an in-range level of H. pylori with no virulence factors at all and no symptoms that match the H. pylori, you might not aggressively or maybe would not even at all treat H. pylori specifically.
That would be correct. Yeah.
Endotoxins, lipopolysaccharides, or LPS, they get a lot of attention in recent years as primary drivers of inflammation and chronic disease. So tell us a little bit about where they come from. How important is intestinal hyperpermeability or leaky gut in the LPS discussion? Is the primary goal to reduce the organisms that produce LPS to improve our ability to neutralize and get rid of or eliminate those, or to minimize the translocation from the gut into circulation? How are you assessing for endotoxin burden? And what are some of your favorite tools, like maybe bovine immunoglobulins or other things to help mitigate LPS?
Yeah, so I would concur. I think LPS is like a huge driver of disease all around us, like, Alzheimer's, Parkinson's, multiple sclerosis, cognitive decline, short-term brain fog and chronic fatigue syndrome, depression, anxiety, cardiovascular disease, all these things linked to excess endotoxins. So I think this is a huge driver of inflammation. Yeah, and I see it all. Fatty liver, like that 8-year-old with fatty liver, it's like that's LPS. So yeah, it's a huge player, and rightly so. It's becoming more discussed because it needs to be. Yeah, because the obesity epidemic, the metabolic syndrome, insulin issues, we're seeing blood glucose issues. It's LPS driven, so we really need to target that. There's a few things we have to look at when considering LPS because it's coming from the gut. Yeah, and listen, some would argue comes to oral cavity too, so there is certainly some data around that, but that's not my area, so I'm focusing more lower down. It's 3 factors. Yeah, one is the proportion of gram-negative bacteria in your gut, and particularly very pro-inflammatory LPS producers like Enterobacteriaceae family. All right, so I'm looking at that. 2, gut permeability plays a role. When your gut's more leaky, more LPS gets in. But LPS also causes gut damage too and causes gut leakiness. All right. And thirdly is colon transit time. And this one doesn't get nearly enough discussion. So I think it's a really pivotal one. Yeah. When your colon, stuff is stuck in your colon for days at a time, you absorb much more LPS load than when things are moving quickly. Yeah, and this is often a huge factor with my patients of going, okay, we've got the triad of things. Is the microbiota composition, we've got the gut permeability, or then we might have what are called colonic permeability, where it's like you're absorbing more from a slow-moving colon. Yeah, and these 2 factors all interplay there. Because you could have someone with lower levels of LPS producing microbes that which you go, oh, that might be okay, but the transit time is really slow. It's a problem. Yeah, and you could have other people who have high levels of LPS producing microbes, but they have no gut integrity issues and they're pooing really well. It's going to be less of an issue. Yeah, so all 3 need to be addressed, though. Yeah, so I need to address healing of the small intestine. I need to address ensuring transit time is adequate and they're pooing really well, and I also need to reduce levels of LPS producing microbes in the gut. Yeah, and for me, selectivity of things is really, really key. And this came through, I did some microbiology work, and it's part of my PhD in a lab going, okay, let's see what impact different home medicines have on the microbiome, both the pathogens and good guys. And I'll sort of firsthand, this goes back to probably 2001, 2002, that, herbs like Coptis, which is really high in berberine, and golden seal, also high in berberine, killed the bifidobacteria immensely well. It left some of the other, and it killed some of the pathogens too, but at the same dose that killed the pathogens, it killed these beneficial species. And for me, that was one of those, again, pivotal early moments. You're like, wow, that did that, but garlic didn't. And there were some other herbs that worked selectively. So why, given how much I want to protect the microbiome from harm, and how much I love things like bifidobacteria, and I don't want to kill them, why don't I use tools that can fix the dysbiotic changes that don't kill the beneficial bacteria? Yeah. So that's been a core part of my philosophy and approach since that early 2000 days of how I part into clinical practice. So we can use tools to target that. And for me, it'd be things like pomegranate skin, pomegranate husk, a great antimicrobial herb that's been used in Ayurvedic medicine for 2,000 years, 1,800 years in traditional Chinese medicine for gut infections. And it's selective. Like it increases bifidobacteria counts, neutral to lactobacilli, increases butyrate producing microbes, but kills a whole range of pathogens, both from Candida and Giardia through to E. coli and Klebsiella and Citrobacter and Pseudomonas. Like you can list off a whole bunch of pathogenic bacteria. Pomegranate kills them really well, but leaves the good guys intact and has anti-inflammatory effects on the gut. I'm like, How good is that? Green tea extract, EGCG, also feeds good bacteria and reduces levels of pathogens very effectively, and has, anti-inflammatory, anti-cancer properties too. So, we can use the right tool to get those sort of, selectively target the proteobacteria populations, because I think that's a key component, because they're releasing the LPS, which causes gut damage. So, you can give, glutamine and zinc carnosine and things like that to try to heal up that leaky small bowel. But if they're still releasing LPS, it's sort of like putting a Band-Aid on something at the same time you're cutting it. It's like you still need to release the thing that's actually driving the gut damage to allow it to heal up properly. At the same time, we have to make sure that they're actually pooing very well, so those endotoxins are going out. And that ties into die-off reactions too, because you're often prone to quite severe die-off reactions when you're targeting, when it can be really high levels of proteobacteria. Like when I have those patients that are, 40, 50% proteobacteria, that die-off reaction is horrific. Like it's really extreme. And it's even more extreme if they're constipated, because you're killing the bacteria, releasing the LPS, and it's just sitting in your colon for days, and then they get immensely unwell. So we have to make sure they're actually pooing really well, so that pathway is clear, so they're actually not just reabsorbing the endotoxins from their gut in such high degree.
So a couple of things on that. When I heard that work of yours, one of the things that concerned me was people that are using berberine for life, essentially for metabolic syndrome and insulin resistance and all of that.
Yeah.
Doesn't sound like a great idea based on what you just said. The other piece there is, if we're talking about motility, even bile flow, moving things out of the intestine to minimize the lipopolysaccharide and endotoxin, it seems to me then like there could be a place there for coffee enemas as well. Do you support that or not?
I'm pretty neutral when it comes to coffee enemas. I don't think I'm okay with it, something helping them poo, but I think I get better results working from the up down rather than down out. And there is occasional patient we have to do the down out at the same time, that when their bowels are that really slow. But I think that I generally try to prefer, okay, let's take stuff that helps work from the inside out and flows down, because that's the natural flow of the movement, rather than just taking out the last bit and then stuff comes to replace it. But yeah, there's a time and place for such things.
Since the emergence of SARS-CoV-2, have you seen meaningful changes in people's microbiome composition, either in people with acute infections or those that have gone on to develop long COVID? Where do you stand on the theory that SARS-CoV-2 may act as a bacteriophage and infect our own beneficial flora, and thus create an internal spike protein factory within our GI tract?
Wow, I hadn't heard the last little component before about the internal spike protein factory. That's interesting. Yeah, it's been interesting because I was doing stool testing before COVID, during COVID, post-COVID. Yeah, and there's certainly some people who had no impact on the microbiome at all. But there are some populations that where it definitely did. Like I still recall in the early days of someone whose season was quite lovely and beautiful and really stable. And then the next result came in, we're like, what the hell? It's so different. Like the good guys all went down and sort of pathogenic bugs all went up. To say very clearly, very simply. And he had COVID, and this is back in the early days. I'm like, okay, that was the only thing that's different. No change in supplement regime or stress or anything. It was just that. And I was like, okay, that had a bigger impact. And I do think what I've seen is people who do develop long COVID or more severe COVID infections are the ones where it seems to have impact on the gut and the microbiome component. Whereas other people they'll get no gut symptoms with it. There's no microbiome changes with it. And other people, there is. Yeah. And you do often see the reductions of butyrate producers, reductions in bifidobacteria, and increase of E. coli and cousins and Bacteroides is probably the sort of pattern you see. And that's the same pattern that drives chronic disease across the board, to be honest with you. It's like the same patterns we tend to see, with some variation with that, with things like Parkinson's and multiple sclerosis and Alzheimer's, and most other chronic Western diseases. But it's a pretty similar pattern. Not enough butyrate producers and bifidobacteria, increased levels of E. coli, proteobacteria, cousins, and Bacteroides is like a very common dysbiotic state that is behind most Western diseases. Yeah.
So building on that, then some would suggest that the disappearance of bifidobacteria is kind of a defining feature of the modern microbiome. So what do you think is driving that loss? How do we restore bifidobacteria, particularly in people that have the FUT2 or FUT2 genetics, the whole conversation around secretors versus non-secretors? Are there ways to mitigate that specific issue? And then have the HMOs, or human milk oligosaccharides, proven highly beneficial in restoring or optimizing bifidobacteria in your clinical work?
Okay, I'll answer the last question first. I don't think I think they're actually inferior to things like lactulose and GOS and human FOS. Yeah, for that respect. I do use them from time to time because they're less gas forming than those other options, and they might be better fit for a particular person in terms of their transit time and disease states, etc. But you actually will see more profound changes from something like lactulose than you will from like 2FL. Yeah, so as I said, I do use them, but I just don't see the impact as profoundly as you would with some of the other prebiotics. Yeah, and some of the FIT2 stuff has been reevaluated with more research coming to date. Yeah, and that it actually doesn't matter so much. And I think that I'm kind of in that camp too. As some of the initial studies were relatively small and they showed this really profound effect. Later, large studies looking at much larger populations didn't find any significant connection between FIT2 status and any microbiome changes. Yeah, and I can't say I've seen it as a huge clinical thing in my practice either. But you're right that I think lack of bifidobacteria is definitely an issue in Western populations. Antibiotic use is one of the factors, but also dietary factors too. Like I think most people don't know this, but ketogenic diets kill off bifidobacteria too. And we've got human data on this, and ketones themselves kill bifidobacteria. So it's very, it's known. High protein, low carb diets reduce bifidobacteria counts. High fat, low carb diets reduce bifidobacteria counts. Antibiotics reduce bifidobacteria, and the Western diet that's just fiberless reduces bifidobacteria. So I think between that lot, it kind of explains why it's not uncommon these days to find low levels of bifidobacteria on a stool test, and sometimes below detectable levels. Thankfully, it's often restorable. Maybe unless they've been on carnivore for like 5 years or something, then probably not, because they've starved it out of existence. But it was, for a while, it seemed to persist there in lower amounts. That's retrievable if they get off that kind of dietary protocol. But antibiotics are ones that, if there's a lot of antibiotic use, that can go extinct from that case. No matter how much I try to feed it up, it's gone. If you can feed something up, if it's below detectable levels but still there, I always say it's at the edge of extinction. It's hanging on by its fingernails on the ledge. You can feed that up and it can come up. But if it's truly gone, you can't feed it up. The only way you can do is really either intentional or accidental FMT to get fecal exposure to someone else's bifidobacteria. I think there's some research, been a while since I read it, but in Japan, in traditional hot tubs and onsens, where people were able to pass bifidobacteria strains between each other because there was no chlorinated water or anything like that. So they were able to sort of accidentally do sort of very basic FMT just from being in the baths together to much more deliberate FMT type approach, because we know sadly that just taking a bifidobacteria probiotic isn't going to persist and stay in the vast majority of cases. Like it'd be immensely rare. I've seen it once in 25 years of practice. A lot of stool tests, one person be able to colonize with a bifidobacteria based supplement, and that's from doing it daily because he was extinct for sure. He was doing it daily for years alongside 3 different prebiotics and bifidobacteria made homemade yogurt and things like that. And that eventually colonized over years of consistent use and prebiotics at the same time. That would feed it up. It engrafted properly, but typically the ones from supplements don't engraft. So we're getting benefit while they're transiting through your gut, but not actually engrafting per se.
So would those people then that had low bifidobacteria but were not able to restore it without that exogenous support be best served to continue to take it for life or until they could find a way to get it to engraft?
Yeah, if you had none and you've tried and you can't, it is truly extinct, then yes, I think there's definitely an argument for taking some bifidobacteria daily to get that that functionality. There's certain bacteria in the gut. I mean, there's quite a high degree of what we call functional redundancy, in that there's a number of bacteria doing the same tasks. So if one isn't there, someone else will do it. Yeah, and you might put butyrate in that category. That that there's some unique, like Faecalibacterium is relatively unique. I'd say that's the keystone species. So is bifidobacteria. So is Akkermansia. There's a few that are like your gut doesn't function ideally, I think, when they're not there. Whereas other ones, it's like other bugs can step into the plate and just do the same job that the other ones are doing without any sort of drop in functionality. But bifidobacteria is in that category. So yes, I think if you are truly extinct, then taking a bifidobacteria as a supplement or making a fermented food out of bifidobacteria that that's in it on a regular basis, as in daily or every second day, will make sure you're getting that functionality that you'd otherwise be missing. And I think that's important from a longevity perspective too, because I think one of the key bugs that's important for health span and longevity is bifidobacteria. Yeah, and there was that woman who died at 117 years of age, and the number of days on top of that, she was 40% bifidobacteria, 40, 50%, I can't remember which, in her ecosystem. Yeah, which is immensely rare. You don't see that very often. Typically, as people age, the bifidobacteria goes down, 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 down.
Maybe we need to do FMT with her stool.
Well, yeah, I wonder if I imagine some researchers actually did grab it and take it and have frozen some samples of it, because that kind of poo would be rare. Yeah.
So I want to think about this from an environmental toxicant lens and how heavy metals, pesticides, plastics, chemicals, all of these environmental toxins might impact our microbiome. We know glyphosate, they used to say, well, it doesn't impact human cells, but it does have an impact on our microbiome and thus does have an impact on humans. So can we think of efforts to either minimize the incoming toxicant burden or tools to help support detoxification and drainage? Can we think of those as an indirect strategy for improving microbiome health?
Yeah, and those are all good points you mentioned too, because all those things do have impacts on the microbiome. Not all those things have been teased out super well, but to date we can say consistently that the microplastics and heavy metals and the environmental chemicals and pesticides do reduce levels of bifidobacteria and butyrate-producing microbes and increase levels of proteobacteria and Bacteroides. That seems to be a relatively common path between all those different chemicals. Yeah. So ideally, yeah, I tell my patients is eat organic as much as you possibly can. Never store your food in plastics, or try not to buy food in plastic as well, for that matter. You buy food from the local farmers market as much as you can. There's a few things like that we can definitely step in to reduce the thresholds that we're being exposed to. Yeah.
I want to touch a little bit more on diet. You've already commented on concerns around keto and long-term carnivore. A lot of the people in our listener community are dealing with mast cell activation, and they're very sensitive to histamine, and maybe are on low FODMAP, low oxalate, low lectin, these restrictive diets. I think that also crosses over into kind of the limbic system impairment, mast cell activation syndrome realm, where people are really sensitive. Maybe they're only eating chicken and rice. I had one client that was only eating one food, and that was alligator, and she had to get it flown in from Florida. So my thought process here is, does that dietary restriction lead to a loss of microbiome diversity because we're not eating a diverse selection of foods? And does that loss then in dietary diversity that impacts the microbiome itself make it eventually more difficult to reintroduce those foods, because we've then lost a lot of the organisms that would help us be able to tolerate them? And then I'm also building on that, wondering if we're restricting oxalates, for example, does that potentially lead to a loss of oxalobacter in our microbiome? If we're not eating oxalates, then what is that bacteria going to stay around for? So talk to us a little about how dietary diversity correlates with microbiome diversity, and how restrictive diets might also then lead to less diverse microbiomes.
Yeah, and that is clear too. The research is clear, and my clinical pattern is clear with patients. If you restrict plant foods from the diet, the type of plant foods, diversity of plant foods, you reduce diversity of the gut microbiome. That's very clear. When it comes to oxalobacter and oxalates, you're spot on. Yeah, oxalobacter only eats oxalates, nothing else. So if you completely cut out oxalates, you will starve that one out. There are other microbes in the gut, like E. coli, that can eat oxalates, and a bunch of other things. So sometimes you give something else with a bit of redundancy built in, but not everyone does. For many people, oxalobacter is the key microbe eating oxalates. And if you didn't need to, but did go low oxalate because you've read online that oxalates are really horrible and nobody should be eating them, and you've essentially starved off your oxalobacter, it goes extinct, then you try to have some oxalate foods back in, you could be worse off as a consequence. So I always tell my patients who even are oxalate sensitive is reduce it down to below that threshold, but you don't want to have none, because you want to make sure those bugs are fed, and we have to work on other strategies that help mitigate maybe excess absorption of oxalates or secretion of oxalates, etc. Because there are consequences there. And it comes to other microbes too. You eat a really restricted diet, like I said, like what I call end stage carnivore. they're one of the hardest patient groups to work with because they have starved off their good bugs so much. They usually have such a high degree of visceral hypersensitivity in the nerves in the gut to all the hydrogen sulfide gas they produced, because they've shifted the ecosystem to being hydrogen sulfide gas producers typically. So high levels of bilophila, the sulfovibrio. Hydrogen sulfide gas makes the nerve sensitive. It's called visceral hypersensitivity. So you try to reach anything back in that's a bit fibrous, they're like, oh, I'll get pain and discomfort from it, and go, yeah, it's causing me damage. It's not. It's just causing a little gas bubble is causing you pain because your gut's got such a high level of visceral hypersensitivity. And there have lack of butyrate producers. They're often really tricky to get back. And because you're just spot on that they've had to degree of gut inflammation. They're missing some microbes, or some that might still be alive, are in teeny amounts, and you have to try to feed them up. At the same time, they've got such a degree of sensitivity to any sort of gas production in the gut. It can be a really challenging group to work with, and you just wish they'd come to see you 2 years beforehand, and they didn't have to go down that path. Because some people are doing it because they just read about it and think it's great. Other people are actually doing it because of their health, and they're going, I feel bad when I eat this, like cutting out that, I feel that bad, I'll cut this out, cut this out, cut this out. And, we could have fixed some of those things earlier, much more easily. They didn't know that at the time. Obviously, otherwise they would have taken a different path, but it is something that I often, when I see those patients, like, oh, I'm inside my head, I'm going, man, I wish I saw you 3 years ago, because we could have stopped this whole, what's occurred as a consequence.
So in the more sensitive patient population, the mast cell histamine intolerance, how do you navigate the beneficial effects of fermented foods or specific probiotics when they maybe can't tolerate the histamine? Is it more about the right time to bring those things in? Do you start maybe with probiotics that are more histamine degrading or histamine neutral? And then building on the fermented food conversation, there are people that are fermenting yogurts, like let's say Lactobacillus reuteri, for example. But if we're getting billions of copies of one specific organism, is that also creating a monoculture that is still an imbalance?
All right. And to last your question first, no. Because the amount, if you're looking at, even if you're drinking like half a cup of, your own homemade, and let's say it's fermented properly and the bugs are really high, it's still a tiny amount compared to what's in your colon. Yeah. Like probiotics, even, the VSL number 5, the original VSL number 3, which is 450 billion bugs, which is a lot more than what you're typically getting in a cup of yogurt. It doesn't do any real changes, any substantive changes to the microbiome when you take that one daily for long periods of time. Even in higher doses, it doesn't have any substantive changes. So I think that's not such a concern. Yeah. And I do think that getting involved with making some selected ferments can be a useful thing. You can ferment strains that have got the additions of actins that you're after. Whereas, listen, I eat sauerkraut and kimchi daily, usually 2-3 times a day. So give some concept around that. But they're wild ferments, and you just never know what you're going to get in them. Yeah. So the only reason I use wild ferments clinically is to improve microbiome diversity, because that's one thing they're particularly good at doing. So if I've got a patient who's very sensitive to fermented foods, we just don't use fermented foods. Like they're not essential for gut healing, the gut healing process. I mean, that should be clear about that. Like I think they can help improve diversity of the microbiome, and that's a nice bit of icing on the cake. But I don't think that they're nearly important as a bunch of other factors. Yeah. So if you can't handle them, fine, don't try to force yourself to do that right here and now. Just work on, improving gut integrity, speeding up transit time. In my experience, slow transit time is one of the core drivers of histamine sensitivity, and microbiome composition playing a driver there too, because you're getting a slow moving bowel, you get a lot more histamine being produced in the colon, and more of your DAO being used to break that down too. So I think it's really vital to look at transit time, and this is, I'm going to sidetrack you, but I think it's really important that sometimes people think if they're pooing once a day, their transit time is great. If they're doing a type 4 log stool and pooing once a day, they must have great transit time. That's not true. I had one patient, we did the home sort of transit time test. She'd never missed a day pooing, type 4 on the Bristol stool scale, that middle one, perfect log, every single day like clockwork. It's 10 days before the corn she ate came out in her poo. Yeah. And it's like, oh, goodness. That was unexpected. Where I've had other people who are only pooing once every 2 or 3 days, and it was 26 days is my sort of champion slow pooer before the corn first started coming out in her stool. Yeah. So I get all my patients across the board to do a stool diary and also a bowel transit time test with initial consultation, because I want to see how fast or slow this is. And that often involves like eating corn on the cob or some canned corn. It can be black or red quinoa. It can be whole sesame seeds, black and white, in the right dose to make sure it's easy enough to see in your stool. Don't use charcoal because it slows down your gut. It does make it easy to see because it's black, but don't use charcoal because it slows down your gut.
How about beets?
Beets, they speed up your gut. So they will give you an artificial response too. So you're trying to choose something that's easy to see, but also doesn't impact the result. And beet and charcoal do the opposite things, easy to see. Some people use a synthetic food blue dye, but I haven't done the blue dye because I just have a hard time recommending ingest some synthetic compound. But it is easy to see in the stool. Most of my patients use corn or quinoa, but I think it's across the board, because if that can be such a key driver that maybe isn't on your radar because I'm pooing once a day and therefore my bowels must be fine. I'm not bloated or distended, but you've got all these other reactions going on with fatigue and brain fog, and maybe you're really reactive to foods. Transit time is often slow in this situation. And if you speed that up, then you actually will see an improvement across the board in a whole range of symptoms, including histamine reactivity. Yeah.
So talk to us at a high level about the role of prebiotics, probiotics, and postbiotics. I think historically there's been so much focus on probiotics. That's what everybody talks about and markets. I would say clinically, probiotics have not been transformative like many people hoped for. So is the greater opportunity in the prebiotics and creating the environment that supports the growth of the beneficial organisms that are already there? Is the issue maybe that we haven't matched the right probiotics to the right individuals and conditions? I know that's one of your areas of expertise. So how do you think about the relative role of prebiotics, probiotics, and postbiotics in creating an optimized microbiome?
Yeah, so I think probiotics, and I put fermented foods here too, are overhyped in terms of optimizing the microbiome. Prebiotics are far more effective, really, and broader dietary changes are far more effective at changing the microbiome in very huge ways. Like we know, it's not like I use probiotics heaps in practice. Yeah, and you're right, it is about matching it in terms of if I want, there's some that work on improving mood or improving sleep, or ones that speed up transit time, others that can speed up healing of the small bowel. Like we've got. It's something that improve immunity, so you get sick less often. There's lots of reasons to use the right probiotic. Yeah. But if it's about changing the microbiome, their impact is minimal, except for really after an acute antibiotic exposure, chemotherapy, radiotherapy, where the ecosystem is really smashed. Then probiotics can play a role in helping it regrow in a certain way and preventing overgrowth of pathogens in that situation. Okay. But 6 months on from that, 2 months on from that, you give them a probiotic, the impact's can be really minor for the most part. Yeah, if you give them some bifidobacteria, a bit more bifidobacteria will show up in the stool test. Otherwise, there'll be no change. Yeah, there's some strains that are a bit more broader capacity than that, but that's probably a good general takeaway. Whereas a prebiotic can cause 100 or 1,000-fold increases of bifidobacteria after an insult. That's far more profound. Yeah, and that bifidobacteria that's there is one that's been in your family line for thousands of years. I think that's a really cool thing that we sometimes don't pay enough attention to, but your microbiome is unique. It's been passed down your family line through generation after generation after generation. And your bifidobacteria in your gut is unique to your family line. And you take prebiotics, you're feeding your own indigenous bifidobacteria population that your family line's always carried, versus I want to pop someone else's, because that's generally come from someone else's family line. Most of the bifidobacteria, lactobacillus supplements came from some healthy person's poo back in the day. And it's not to say that we don't take them, we still do. But, I still think for me, it feels better to encourage your own populations that you've always carried to actually be in an optimized state than even if I could supplement with Joe Blow's bifidobacteria. I still think that's less likely to be a great match for your family over the longer term. Yeah, and I think postbiotics we touched on a bit already too, because I think like butyrate or like the sterilized poo ones have got that niche. I think that end stage carnivore or the really damaged gut with heaps of oxygen tolerant microbes there, very low butyrate producers. I think that's where those postbiotics like that have got a role to play. Yeah, I think that's their niche.
So if we talk then a little more about the prebiotics, and we've touched on many of them, there's many oligosaccharides, the FOS, GOS, XOS, all of those. You talked about lactulose as well, acacia, glucomannan, PHGG is very commonly talked about. So are there some of these that are better tolerated earlier on versus some that might feed pathogenic organisms so much so that they're not going to be tolerated when there's a more significant amount of dysbiosis? Is it about the right time, or is it the right dose? Or talk to us about that.
I think it's not about feeding pathogenic microbes. I think I want to be clear here. But you can get symptoms that are unbearable. Okay, like if your transit time is really slow, Like you've got 5 days worth of poo in you, and all of a sudden you blow up like a balloon. You're going to be in discomfort and pain from that. And, and people go, oh, that's feeding bad bacteria. It's not. It's feeding good bacteria. It's just that your gut is not working properly. So listen, if you've got slow transit time, you have visceral hypersensitivity where the nerves in your gut are hypersensitive to things like gas production and or SIBO, which are those things can mean that you will react badly to a prebiotic substance. But in all bar SIBO, you're not actually feeding bad bacteria, you're feeding beneficial bacteria. SIBO one's a bit more unusual because what's happening in the small bowel in SIBO cases is we have a dearth of diversity. We've got like very much almost like a monoculture type thing, usually with things like E. coli or Klebsiella. Now, when there's competition for food sources, like for GOS or lactulose or FOS, E. coli, Klebsiella lose out. They're not very good at eating it. Okay. But when it's the only food source and they've got no other competition there for it, they can kind of eat it. Yeah. And this is why sometimes with a SIBO case, you can have something like, oh, I can take this and I blew up in the small bowel, but it is Klebsiella or Escherichia. But in the colon, you see that their populations actually go down. Yeah, when you ingest FOS or GOS or lactulose very clearly. So it's not like, in the colonic perspective, you're not feeding bad bugs, but you are getting symptoms if you have visceral hypersensitivity, you have slow transit time. Yeah, so I just want to be very clear with that because I think sometimes people misconstrue symptoms with feeding bad bacteria because you're going to get gas with prebiotics. You're going to get gas when you have more fiber in your diet. It's not about feeding bad bugs. You're just feeding beneficial microbes, and hydrogen gas is a byproduct of that. Yeah, that's just the way our systems work. And hydrogen gas has a range of health benefits too. People are like buying machines to put hydrogen in their water, yet they could just be feeding their hydrogen-producing bacteria in their gut and getting all those benefits of hydrogen water. That humans historically always have done it that way by having fiber in their diet. Yeah, so I think sometimes the ones that are most broadly tolerated in a wide population of people, because I work with a lot of people with SIBO and great sensitivity. So, PhD is often the safest one. So partially hydrolyzed guar gum. It feeds butyrate producing microbes. It has a normalizing effect on stool form. So it can soften it when it's too hard. It can harden it when it's too soft. It speeds up transit time, but it can also slow down transit time if you've got acute diarrhea. It's a very cool substance, but usually well tolerated. Not across the board. Like, some of my patients can't tolerate it now, but most people can tolerate it really fine. 2FL, like when the HMOs and acacia fiber can sometimes be better tolerated in some people who've got some more gas-related issues. GOS can sometimes be better tolerated too. Like there's a number of studies giving GOS to people with IBS, showing decreased gas output. But again, there'll be some people there who get a flare of gas symptoms when they start on GOS, other people not. And sometimes you just start low and build up the dose. So I always say start low and go slow. And lactulose and even FOS are definitely more gassy of that list and more likely to cause bump up of hydrogen production. And when your gut's working well, that'll just be manifest as flatus. You're just going to fart more for the first week when you take it. Yeah, and that's it. It's just when your gut's not working well, where it's moving slowly or your nerves are sensitive, you'll get pain or discomfort associated or worsening constipation, which is usually a sign of methane issues that need to be addressed anyway. If your gut slows down and you get more constipated when you take prebiotics, that's usually a methane issue, and you address the methane and sort that.
I know one of the things that you've created is Probiotic Advisor. So talk to us just for a minute about how specific to various conditions the selection of the beneficial organisms might be. I know we talk about psychobiotics to support our mood, anxiety, depression, and so on, but are we starting to get to the point where there's probiotics that are more appropriate for maybe conditions like Lyme disease or multiple sclerosis or Parkinson's or Alzheimer's or maybe kids with autism, PANS and PANDAS? Yeah. Talk to us about what the research supports and what you do with Probiotic Advisor.
Yeah, so Probiotic Advisor essentially grew out of my teaching around probiotics and using the right strain for the task, because we know that probiotic characteristics are strain specific, not necessarily species specific. There's some that are like producing lactic acid or acetate can be like species specific, but there's certain things that are very much strain specific that could be, I'll give you an idea here. Like there's a psychobiotic called Lactobacillus plantarum PS128, and it was isolated for a number of strains in a Taiwanese fermented mustard green dish that's, they've been eating for thousands of years. They isolate a bunch of lactobacilli, put it through a bunch of obstacle courses, and which one could increase GABA flow and could tolerate stomach acid and bile salts and all those other criteria too. And it turns out they found one strain that did. Yes, not all L. plantarum strains do this, but this one does. Again, at the conference I was at in South Korea, they're looking at lactobacilli that could modify the MAO, monoamine oxidase system. And they started with 200 different strains of from kimchi, and they found one that could actually have MAO inhibiting activity. So some of these things are very uniquely to that strain, and that's why they go into research studies, and we actually go, yeah, that actually works. So the PS128 strain of L. plantarum has been used in Parkinson's disease. It's been used to improve sleep quality, and so for people with insomnia. It's been used in kids on the spectrum, where it helps balance the mood, particularly irritability. Yeah. So we've got these kind of things where it's very clear, where another type of lactobacillus plantarum will not have that same effect. Yeah. And my database is kind of set up where we're looking at the research, we're summarizing the studies, we're showing where the strain can be found commercially in Canada, the US, and Australia, to make it easy to prescribe probiotics in an evidence-based manner and matching the best probiotic for the disease or symptom that person has. Yeah, we're trying to make this as easy as possible. And that started off with, I had 3 different paper documents back 20 some years ago. And eventually that's because of the increase of research and just trying to make things simpler. We now have that electronic searchable database, because I think that's key. If you do that, you get much better results with probiotics than you do if you just randomly throw high CFU things at things. You get very poor general results with that compared to actually targeted probiotics that, your transit time is slow. Let's give you a probiotic that speeds up transit time. Your mood is low. Let's give you a probiotic that it definitely improves your mood or improves your cognitive capacity. It's very, very clear that we get better results when we're targeted with our probiotics.
So when we talk about FMT, do the benefits outweigh the risks? Does that depend on the severity of the person's condition? Are there risks from your lens? And do you think that we'll get to a point where FMT will evolve to a place where only beneficial organisms remain, and thus it's kind of a super probiotic? What do you see as the present and future of FMT? And are there any other tools that even approximate the potential benefits without the risks?
Yeah. So, I think generally the risks of FMT are relatively small. Yeah. Not none, but I think relatively small if the donor is well chosen. Yeah. I think the risks are that we're still not fantastic in matching the best donor to the best recipient yet. Yeah. That's where I think the risk is. And occasionally, like I remember having one, I work with a fair few kids on the spectrum, and there's one family came to me and they had FMT done, and the first donor stool was great. Like within 24 hours of getting FMT, they started verbalizing, and there was eye contact, and they were responding to their name being said. Huge leaps from beforehand. And that kept getting better for, I think it was 6 weeks on that first donor. And things were going great, like light years better than what they were before. Changed to a different donor, and then 24 hours later, regressed back to where they were before. Yeah. And that's one of those cases wow, okay, the wrong ecosystem for this person actually completely negated all the benefits that were there. Whereas, that's been relatively rare. Most of my kids on the spectrum, either the FMT has helped a lot, a little bit, or been stable and done nothing. And it's just, and also knowing the broader FMT literature is looking at, IBD cases, which there's been a fair bit of positive research. And again, we're still not fantastic of matching, getting the best donor. We're getting better at it. But I think it's also hard getting great donors in Western nations. It's I want someone who's was born vaginally, breastfed, minimal antibiotic use, if any, as a child, grew up eating organic whole food diet, no antibiotic use in adulthood. It's just you're looking at a unicorn here. One in 100,000, one in 500,000 people that actually fit that criteria, which makes it very hard to find them. And I think their poo is going to be immensely valuable because of that capacity, but they're rare. And I think that is why we haven't necessarily seen sometimes the best results as we could. Now, that said, we had positive results in metabolic syndrome, type 2 diabetes, type 1 diabetes, lupus, Parkinson's, Alzheimer's, cognitive impairment, with ankylosing spondylitis with FMT studies to date. Yeah. But I do think that we'll generally get better hit rates and better results across the board when we are better at matching the donors and recipients. And already we've come a long way from, with C. diff, it didn't really matter. If you had antibiotics in 3 months, you're going to fix somebody else's C. diff. Yeah. So donor quality didn't matter. And I think that's kind of, because the FMT kind of research grew out of that, I think they put less emphasis on donor quality initially than what they should have, which is why I think we didn't necessarily get sometimes the better results with that too. Because if your only criteria is no antibiotics in the last 3 months and no disease, you're actually implementing some really unhealthy ecosystems from one person to another. And for C. diff, it doesn't matter because it's better than what they have. But for other conditions, it matters. Yeah.
It has been suggested that GLP-1s may have beneficial impacts on the microbiome. Some are using low-dose GLP-1s for metabolic health, inflammation, mast cells, not so much for the weight loss at the standard dosages. But do you think that some of the benefits that are being observed could be the result of beneficial shifts in the microbiome resulting from GLP-1s? And building on that, are there any other standout peptides that you're using in the gut health realm, whether that's BPC 157 or KPV or lorazepatide? Where do you think peptides fit in this conversation?
Yeah, the latter tools are not ones that I have easy access to in Australia as a clinician here. So I don't have much experience using them, and I've just reviewed some of the research on them. And I think I think for gut healing, I'm still really comfortable with the protocols and tools I have now that work. So I haven't, had a need to delve into using peptides and things like that either. Yeah, and some of the early research is pretty early on some of those things too. And then I've also heard some things too about in terms of buyer beware in terms of what you're getting with peptides too. And I'm sure there might be ways around that, but it does make me less keen to explore that when I've got things like L-glutamine or zinc carnosine or Saccharomyces that works well for healing up a damaged small bowel very effectively, and I've done tons of pre and post testing, so I know it works. With dosage, I know a time frame, etc. So I don't feel the need to go outside that spectrum now of agents. But I think with the GLP-1s, the data on humans from a microbiome perspective is not that many studies yet. Like there's a review, systematic review published just last year that tried to bring all the data together. And so there's only 1 or 2 human studies looking at the microbiome impacts. Yeah. And there's a lot of more animal studies, but it doesn't always replicate what's happening in humans, animal studies. Yeah. And that's the same case with all tools, including GLP-1s. Yeah. So, I think, and each one seems to have a different impact too. I think that's the other thing too, from having a look at that systematic review was like, okay, liraglutide has a different impact on the microbiome. That's another GLP-1, but there's another one that the impacts weren't universally the same between them, So I think liraglutide has been shown to increase akkermansia in one human study, but some of the other ones didn't, or some would maybe decrease bifidobacteria. So I think we can't necessarily say across the board that they're working on the microbiome perspective solely as a key functionality mechanism, unlike things like metformin, where it actually seems it is quite a microbiome alterating scenario that we can give animals metformin, for example, and that fixes their blood sugar control issues. We can do poo transplant to that, give it to rats who have diabetes, and it gets better first from the poo transplant. So even without the metformin, because the metformin's altered the microbiome. So I think we have data in that case that's like this is working via the microbiome as the core mechanism, whereas I don't think we have that with GLP-1s at this juncture time. And each one seems to be a bit different in terms of their impact on the microbiome.
Do you think there's any role for physics in supporting the microbiome? I'm seeing more conversation around red light, infrared light, constitutional hydrotherapy with sine wave, sunlight.
That's going back in time, that one. Yeah.
Do you think that photobiomodulation, photobiomics, do you think any of these physics-based interventions have the potential to help optimize the microbiome?
I'm going to say yes, but it's early days and we don't necessarily have, and I'm less familiar with the research on it, so I can't necessarily say, oh, there's been this brilliant new study showing, abdominal tummy exposure to sunlight improve this or that. There's definitely some data I've seen where, improving sunlight exposure has had some positive microbiome impacts. There's at least one study I've seen on that, and it wouldn't surprise me if there's maybe more since I last looked. And I do think that many of us are divorced from historical exposures to sunlight and how we live our lives these days. So it wouldn't surprise me if there's a definitely connection there. And just like if we're in nature, in gardens, we pick up microbiomes, and our microbiome gets more diverse from just being in wild nature and from gardening. And historically, that's where we've always lived. And it wouldn't surprise me again if we're replicating more of our traditional environmental exposure, that being in the sun and getting outdoor exposure actually is going to improve a whole range of health benefits from that, but including our gut as well.
My last question is the same for every guest, and that is, what are some of the key things that you do on a daily basis in support of your own health?
Yeah, so a few things. Like I think daily meditation is important. So it's like, just helping to work on that stress axis. I've been meditating for 35 years or something, so a long-term meditator. Eating, but from a microbiome perspective, is eating mostly plants, eating a wide diversity of plants, a rainbow of colors, and organic gardening. And I buy my food from local farmers market. I think that's key. And I've got a beautiful garden full of like edible stuff. And I'm always out there harvesting 12 months of the year. So I moved climate. So I moved, 2,000 kilometers or 1,500 miles closer to the equator so I could grow and have a better growing season and better growing climate for farmers markets too. Yeah. And that, with a microbiome perspective on that as well. Yeah. I mean, I think it's high fiber, prominently plant-based, and lots of rainbow colors. I think those are some of the key things for enhancing microbiome health that are really key principles. And having time outside too. Like for me, the most nurturing thing I can do is go for a run on the beach and a swim in the ocean, which now I live in a climate that I can do that year round. So it's like, I love that. And I think that for well-being, so just sunshine, exercise outside, fresh air. I mean, all those things all can get wrapped together with that kind of experience. Yeah.
Dr. Hawrelak, this conversation was so rich and diverse, and I enjoyed shooting the poo with you over the last couple hours. I really feel like you're a very kind and gentle soul with very high intention, and it is a great honor to have this conversation, to know you, to interact with you, to learn from you, and I just really appreciate all that you do to help all of us. So thank you so much.
Oh, thanks, Scott. That's lovely. Yeah, no, you're very welcome. I enjoyed our conversation too. Yeah.
Thank you for listening to today's episode of the Better Health Guide podcast. You can learn more about today's guest, including relevant links and resources, in the show notes. This podcast may provide community discounts and occasionally share links from affiliate partners. You can find this and other episodes on YouTube, Spotify, Apple Podcasts, Amazon Music, iHeart, and more. To learn more about Scott's personal journey to better health, visit betterhealthguide.com. Join us next time on the Better Health Guide podcast.